I can tell you want a party. Oh, sorry about not working yesterday. I didn't work. Yeah. Well, I did actually do an important problem. I can show you. I added thing to the bot file here. So where does it say Tuesday? Yeah. So November 6th, a month ago. Is it a month ago to the day? No. I was writing this encoder for the bot. Where's the master branch? Oh, it's way down there. Okay. I was writing this encoder for the bot file format, and why would I do that? So I was thinking, bots v2. I'm verified. Let's go. This one. No. This one. So I was thinking that I would make a new file format because, oh, I should actually write this down. That is not how you spell that. Because several factors. So this is the original reason. This is the one issue that I have with the current file format. And then Roblox added buffers. Okay, the current one's kind of like fast enough. But if I was going to do a rewrite, I would rewrite it using the buffers. And then this one is like an improvement I would make. It doesn't change the functionality, or it doesn't really change the data it can represent or the data represented, other than it's the format is a little bit different. The payload data wouldn't change. It would just be, I would just write it a little bit differently. So like these are all things that are like building to why I would want to make a new format. I don't think I'm going to do this. And then recently, last month, I think Roblox added compression, and what else did they add? Hashing and compression. I'll directly upload to storage. Using Roblox hash thing. Yeah, so these two things were added together in one update for Roblox. Amazing update. I wish these were around when I wrote the file format in the first place 3 years ago. So that's why I was working on it. I sort of got to a point, and then, oh yeah, so this was the point, November 6th, and I was like, oh, did I delete the comment? I had a comment like, this is wrong, I did it wrong. And I fixed it. So it took some thinking, and I did this yesterday off stream. So cool. Good job, me. Basically, I wrote the timeline in the wrong order. The timeline was being written in block ID order, but it needed to be written in chronological order. And so I could have just sorted it afterwards, but that relies on floating point to do the sorting, and like it was already in the correct order in the first place. So why would I jumble it up and then resort it? Like, that's slow and bad. So I came up with a method to make a dummy timeline and then just fill in as you go through the items. Because you don't know the block ID. So yeah, this fill the timelines with dummy values. You don't know the block IDs yet. Yeah, so we're like discovering the block IDs through this algorithm. So I just wrote down the index ahead of time, and then it knows where to set it within the timeline, and then it also has this field. So it just already knows what index it should be in, and so it never gets unsorted. It just uses the original order. So awesome. Very cool. Yeah. I could actually do this faster with unsafe, but I'm tempted. I'm pretty tempted. I just know it can be done. Strafes. Why don't I write it? Did I write it? Oh, I didn't write it. I'm gonna write it. Why not? So how it'll do like this, and then it'll do like this, and then it'll do like yeah. Spare capacity. This is all one big goob right here. So what if I like do this? There's no goobs with that, right? All right, now this is unused. So then we go like, I'll just like, I'll call this uninit equals, dot spare, yes, that one. So then we go like, instead of doing like this, you do like this. Instead of do like this, you do like this. And I did that, right? Oh, I did vec, oof. Very true, very true. So we actually, this only needs to be a mutable slice. Oh, it's already mutable. Hello, gamers? Maybe in it. Very true. Very true. Can I just underscore here, man? Can you just like let me underscore here? Close your parameter here. Yes, so dot right. Type annotations. Cringe. Yeah, like Why? Okay. Okay. Cringe. Okay. So that writes all of the values guaranteed to the spare capacity. Guaranteed. And then we have to set the lengths unsafely. Unsafe. Yeah. Boom.setLen. Can I the new length is this. Yep. Yep. Safety. All values have been initialized. It was moved. All right. We'll do it all the way up here. It's a very, very popular. Sure. Num offline blocks. Bam, bam, bam. And then, yep. There we go. Yep. Yep. So, but whatever. Yeah, no. Yeah. So that was just, I just did that. No way. Yeah. There should be no problems. It's just a little bit, tiny bit faster. And if I'm going to run this on a million bot files, maybe I do want unsafe. Use unsafe to construct list. Plus 57. Yeah. Sure. GG. Okay. Why am I coughing so hard? Strafe. Yes. Yeah. It's not gonna work, is it? Unlucky. Okay. Wait, what? V0823. The len is 1. How would the len... Did I write the wrong thing in here? Offline, real time. Offline, real time. Offline, real time. Oh. Huh? What? Does it do that normally? Okay, how did I how did I mess this up? Okay, that's a lot of bytes. So that looks like that succeeded, and this is now failing. So I have actually not written unsafe correctly. Fantastic. Okay. Offline is offline. Real time is real time. Unsafe. Yeah. Okay, so if I just take this and I go, like, whoa, why did that go there? Like this. And I go like this, and then like that. That should help. Tab, group. And then now I can rebase this, and it'll... And now it looks cleaner because it doesn't include tab changing as well. How did I mess this up? Oh, there it is. Okay. At the very beginning. All right, so now it fails to test it a different way. Let's go. Okay, so now the code is equivalent. Hooray! Okay. Mm. 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 Mm-hmm. 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 Is it because the vec doesn't have the type shown? I guess. If I say the type directly on the vec, would that work? Maybe. It just matters so little. The amount of performance gain from this is just so little. The main bottleneck is the allocation. And like cloning this value, which is what? 8. Okay, well, yeah, no, it'll be 16 bytes. I just filling it with zeros is just not expensive. But like I just know a way to do it better, and this is my library, so get wrecked. I love this thing. Spare capacity mutt. It's crazy. Makes me feel like a champion. Speed champ. Even though I like haven't benchmarked it, haven't tested it. And it doesn't even work properly yet, so speed champ. Let's go champ. The phlegm attack. Okay. All right. I was not going to work on this, actually. I was going to work on the game the game. Okay, physics. Yes, physics. Right. Okay, so I was gonna go grab this stuff and bop it on to like most of here. And then test simple meshes. Lifetime. Yeah, it gets rid of lifetime. That's cool. The lifetime is now part of the generic. I think that's really cool. Okay. So we can probably not oh yeah. To do unit tests. Okay. Okay. Oh, did I change it? Right. Okay. Is it gonna get stuck here or there? Yeah. Okay. Okay. Now we're in the weeds. My God. In the weeds. Okay, so we need the new stuff. Oh, we're gonna need M and C. That's kind of cool. Okay, I'll just use this. I'm not gonna get worked up about that. Where's the stuff? Okay, so use both. Yes. So new. Minkowski vert. Yep. So we need MC, 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 A. Wait, that's Imple. Oh crap. Right. Okay, there's no lifetime. Oh no, there is a lifetime. Okay. M. Okay. M. Yeah. Okay, so this is the Imple block. Okay. Yep. Okay. Crawl to closest EV. What is doing? Right. We need both. Yeah. Okay. So yeah. Do we just zoink it and it's good? I think it's good. 3. I think this is good. Yeah. Whoa. Okay. So oh no's is not real. We actually only care. Yeah. So this is the new signature. Like this. And then that's it. And this is not real. And then this is, it doesn't work. But that's kind of okay. Wait. Does the closest fab not inside versus, wait, where's the other function? There's closest fab not inside, and there is intersecting type situation. Contains point. It's all the way up here. So this is the only thing wrong with the contains point. That's kind of neat. I might actually have a good, good. Okay, so we have buggings here. Okay, so we have from EV for Minkowski mesh. So this is it doesn't actually matter what the F is. I think we can just say oh, it's an M. Oh, no. Okay, it's an M MeshQuery. EV M yeah, and then V fev M. Oh, come on. Really? Edge, undirected edge. Really? Do we really need to say this? That's so silly. Thick line. Oh, we need an M? Oh, it's just a new M. Yeah. New M. Oh. Yeah, okay, vert. Oh, MeshQuery. Yeah, man. Yeah, man. Why is, oh, yeah, okay. Yeah. Crawl. Is that even, what? Crawl close to see. Okay. Sure. We'll do that. M, and then we need to copy the EV crap from right here. Garbage. Yeah. EV. Vert equals M. This is a lie. That's a lie. Why is this M? You're lying. Oh, it's, oh, I'm dumb. Okay. Okay, so then this doesn't work. I could make some gooberts here, and then it would work. Yes. Maybe I should just make the gooberts, because like this is valuable, and I want to test it. I have didn't I try? And I'm like, oh, if it equals, then it just like was not constrained by any types within the thing. Where normal mul, and then I would need to like mul, and then get that. It's just annoying. But then like, oh, crawl to closest fev. Ew. Well, EV works. That's pretty cool. Ugh. Wait, shouldn't I write EVM instead of this crap? M MeshQuery, and then I can do mvert m this crap. And then I can say EVM, and it's shorter everywhere else. Jeez. Yeah. So EVM instead of this crap. Nice. Nice, 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 nice. Okay. Shorter. Okay. So I'm gonna grab all of this except for these two functions. Crawl to closest fev and closest fev on side. Those ones cannot be converted. Oh, it's crashed. That's right. Okay. Okay. Yeah. Do we get any underline? Oh no, it's just trolling. Okay. So what's the problem? Closest fev on his side and crawl to closest fev. It's those two functions, right? So I could like write it. Yeah, I could just go revert and then revert. And now it's written. I can go like this and this. And Minkowski mesh is not in this scope. Minkowski vert. Ah, I see. I removed all the crap. Oh. What about this? It's nice that I saved this on a branch because it was it's turned out to be useful. Mesh contains points. What a useful function, right? Does this mesh contain this point? I would really like to not do this. So this is like assuming that the mesh is a Minkowski mesh, and it's switching mesh 0 and mesh 1 so that the algorithm that assumes the other way around works. Really, I should just change my assumptions in the rest of the code or change the algorithm here to work using the like reversed assumptions. Great pain, great pain. I'll figure it out. I'm thinking about Git stuff. Like, how do I make it a separate thing? Okay. Okay, so I took away the names of the things, and you cannot use the names of the things. Should I want to test this function. Such pain. No. No. It's backwards. Okay, I just need to ignore it. I just need to ignore it. Okay. Does that mean, okay, what does this mean for a normal mesh? Isn't that nothing? I think this is a no op for normal meshes. So I could actually I can make a freaking trait to band-aid it. But that doesn't fix this. Oh, Minkowski vert, that's right. Minkowski vert. Use Minkowski vert. Minkowski vert. Minkowski mesh. So, yeah, these ones. Jeez. To do. Remove negative mesh. Mesh invert. I just like gotta do it. Use create model. I'm trying to make it exist first. You know what I mean? Like, just the code has to exist, and then it can be nice. Okay, what is going on here? That's the oof. Really? Really? M. Oh, there is no M. Okay. Minkowski mesh. Yeah. Okay, so then this one, we can just say underscore and it'll just figure it out. Can I do this? Aw. Yeah, Minkowski guy. Haha, I'm Minkowski. Okay, so that actually will compile now. Okay, so that is like the full thing, and then I revert this comment. Revert. Yes, revert, and then this is the full thing. So MD generic goes right here, and then this one is squashy, partially implement MD generic. Yes, and then so now it's generic. Wow. Across MeshQuery trait. So if I have a mesh that just has faces, then I can use this algorithm. I can just go like, okay, is this point inside this mesh? Wow. And then if I have a mesh that's composed of two meshes, that's a Minkowski sum of the two meshes, that also implements the MeshQuery trait, and I can use that too. But not really, because it didn't go in full. So like I need to delete this and delete this like mesh swapping thing, because the inner algorithm here, it has backwards assumptions, and it's not compatible with my current code. And I think that my current code is actually the sort of non-intuitive one, the illogical one. Wow, really this? Yeah, oh, I see. Okay, I see. Right, this is backwards. Okay. Wait, I added a comment. Oh, I'm stupid. Okay. Yeah, dummy. Don't. Okay, edit comment contents. Okay, danger. Okay. Don't have this L. L. And one more right here. Contains point. Oh, wait. I never added that one. Okay. No. Comment, continue, take theirs, continue, bam. Okay, so this should be the same. So now there's no commented code. This just contains the generic stuff. Okay, so the difference between this and that is that I added this EV state machine, and I added an algorithm for the edge case, literal edge case, the case in which it is crawling across the edges of the mesh. And it removes the error case. Very awesome. There is no more error. There's no way it can possibly error, except it does anyway because the algorithm is wrong somehow. Okay, cool. Good job. Okay, we push this branch and destroy the old code. And then we pull this comment into this guy. And so now it's partially implemented as generic, and I can test the individual functions. Fantastic. Rewrite physics. Okay. Does it work? Let's just run it. Strafe. Build. Release. Yeah, okay. Tools. Arcane. Okay, so it should just work exactly the same as it did before. Which is, it luckily works for the edge case that I care most about, but basically doesn't work in any other case. And that edge case is box on box collision. So if your collisions are a box and a box, it can pretty much figure that out. But if you go like this, it's like, whoa, and it just like passes through. Yeah, jumpy, yes, amazing. Physics, good job, physics. Okay, so I can't believe it's not a face. I can't believe it's not butter. Oh, too far. So it just looks like it's working, right? No. So here is a non-axis aligned box. I actually haven't tested this. I don't know how well this will work. Let's see if we can run into it. Nope. It just doesn't work. It just doesn't work. Oh, dear. Yeah. Oh, that worked. Now it doesn't. Now it does. Yeah, so basically different setups will work or not work. I bet this could work. Oh, it does. Wow. Huh. I couldn't tell you how that affects the algorithm internals. Okay. So now that I have all the functions are like generic. All of my... Where's the... Oh, it's all up here. Reduce, right? Reduce. Yes, MeshQuery. So all of the functions are generic across the MeshQuery trait. So I was going to just like call these functions and just have like dedicated tests for each function and see if each function does what I expect it to do. Like ideally there would be a test for each case. I don't have good mesh generation. Oh, I don't have a good like way to construct a mesh. It just is gonna like, I'm just gonna have to like construct the meshes manually. Oh, I forgot. The pain of making your own game engine. I can't just make a cube. I have to like specify every vertex, specify every edge, specify every face. And like I've just avoided doing that thus far. I've done it once. Whoa! Did that actually land? That looked like I actually hit it. No, it didn't. No, it just kind of looked like it. Yeah, no, it was just like that. Yeah, there's one cube defined in the entire software. In model. And you might be able to spot it if I just scroll down. Yeah, it's up there. This is the cube. Unit cube. So this is why I'm like moaning and groaning about making a mesh. Wait, I can just use this function. Physics mesh. Oh, I'm chilling. Okay, I just say unit cube and we're off to the races. Okay, let's go. Let's go. Let's go. Okay. I forgot. I can just call this function. Okay. God. Oh yeah, I was thinking of making this generic as well. Isn't that funny? Just so I can have like a static cube. Very funny. It's doable. Okay. Okay. Don't need to do that right now. Do not need to do it. Okay, so I'm going to call the unicube function from a test and then go like, is this point in the cube? Is this point in the cube? Is this point in the cube? And just like compare to like what one would expect and see how that goes. Something like that. Okay. Yeah, let's do that. Okay. Okay. So basically, I want to call all the function. The function contains points. So I want to call this function. But I don't need to do this. What types? Okay, no, that's like that. Yeah, okay. Wait. Simplex 1-3 Minkowski vert. Why doesn't it? Oh, 1-3. Okay. Okay. Stop thinking about that there's like code. Just copy paste, okay? Just copy paste. Unit tests. Wow, unit tests. Woo! Sure, mod test. Boom, we have a function. The function is going to be physics mesh. Whoa, physics mesh. Physics mesh. Yeah, woo. And then we can't do this. We just do that. And that's the only difference. It's the only difference. Okay. Use super everything. Thanks. Okay. What do you want? Trait bound physics mesh query is not satisfied. That's a big lie. That's a lie. That can't be true. Do I have to use transformed mesh? What if I don't want to use transformed mesh? Because, like, it's annoying. Okay, what about physics mesh? Can you... No. Physics mesh. Is there, like, a method on... Oh, physics mesh view. Good God. Really? So I didn't implement the trait for a physics mesh? I feel like that could unlock some... Goodness. Oh, physics mesh view. Oh, okay. So, yeah, no. I can do that. So it's not transformed mesh. We're just gonna do physics mesh view. We're gonna say the left hand like that. Okay, cool. Okay, so it's for physics mesh view. I see. It's because the physics mesh has multiple sub meshes, and the physics mesh view says which sub mesh we're pointing at, or it knows. It's like directly, it knows. It knows. You know, it knows. Okay. Is this clone copy? It is clone copy. Wow. Okay. Oh, good. Sure. Maybe. Okay, whatever. I'm just gonna leave it like that then. Okay. Physics mesh view. Okay, so we need a test now. Okay. Whoa, it's a test. Oh, it's a test. Okay, function. Test cube points. Insane test name. Okay, let mesh equals physics mesh unit cube. Yes. And then mesh view is mesh dot complete mesh view. Do I want? Yeah, no, that'll work. That'll be fine. Surely, right? Surely. Why do I have a new function? Did I ever even use that? Physics mesh view. Oh, that's transformed mesh new. Okay. Obviously. Okay. What other views are there? View. Okay, so there's submesh views, submeshes. Alright, sure. Complete mesh view. There's only one mesh, so that's fine. Okay. It's the cube. It's the cube. Okay, so now we do our widow function. Mesh contains point, mesh view. Does this... Okay. Okay. Whatever. Clone copy. Okay. It's like, yeah, I just like, it just doesn't matter. It doesn't matter. Okay, so point. All right. PP planar v3. Yes, sir. 0. Assert. Mesh contains point. Whoa. Oh, it's like this. Vec3 0. Oh, right. 0 is like this. Okay. So the unit cube should contain 0. Is it like, oh, it is. Plus minus 1 is the unit cube. So it's actually 2 units wide. Okay. Okay. Test harness. Why is this unused import? I'm literally using it right here. Are you trolling me? What? Like if I don't do this here, it's literally used right there. Okay. Okay. Oh, it's CFG test. Okay, CFG test. Okay. Add unit test. Bow. Bow. Okay, run the track. We go to lib. No. Engine. Physics. Test. Release. It's gonna run more than one test. Woo! Okay, did the test pass? Test cube points. Woo! Test passed. Okay. Woo! We probably want to do like this. Is that gonna work? Yes, it is. Okay. Ooh. Okay. We added a unit test. Let's go. Okay. Next up, more unit test. Okay. I want to know X. Is X in the mesh? Is negative X in the mesh? Is Y in the mesh? Is negative Y in the mesh? Is Z in the mesh? Is negative Z in the mesh? Is 1 in the mesh? Is negative 1 in the mesh? They should all be true. And I don't think that they will be. I think it'll go like no. Really? So we went true, false. Okay. What about those ones? -1. Huh. That is very particular. Whoa. Whoa. Add test points. Huh. Well, that's really good. That means that we can instantly find the failure case, he said confidently. Well, we have already found a function call which gives the wrong return value. I think I'm gonna like skip it though. I think I'm gonna try. I'm gonna do divide by 2. I'll just do shift right, whatever. Does this pass? I don't actually know if this will pass. I hope it fails. Ooh. Okay, so I took all the points that were on the cube and I shrunk them by half. So now they're like really in the cube and not sitting on the surface, which is supposed to be on the cube. It's supposed to be able to like find that point. Wow. Okay, let's do for loop. Ugh. Ugh. All right. Okay. What? What? Do I call it vec3 new? What? Oh, 3. New. Int. Okay. 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 XYZ. And then shift right 1. Okay, so that'll test 25 points, including this one. All right, 20, 25? Yeah. Wait, am I stupid? Yes, okay, 125. And it'll fail and it won't tell me why. Okay, so we need to do assert, and then we go like mesh did not contain point, and then the point. And it should just print good printy. Mesh did not contain point. Mesh did not contain point. Yeah. So that was the first one it actually tested there. I can't say I'm looking forward to debugging this. I hope I just print some of the reduction and it's just the logic is just obviously wrong. Yeah, okay. Yeah, okay. 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 Okay, so now I'm gonna make a little branchy branch. Test fail. And we are going to give me this one. Revert lines. And bam. Failing test. As simple as possible. Just the failure case. And we run it, and it fails. So now I can start going in and go like, oh, no capture. And it should print stuff. Except it doesn't because there are no printings. Okay. Minimum difference. Okay. Let's see how much stuff it's doing here. So reduce. Ooh. Okay. I'm just going to like reduce 1. Go for it. I just want to get like a high level overview of what the hell is going on. Reduce 3. We should start with 1 and then print 2 and then print 3 and maybe 4 and then exit. I don't actually know. So let's see. Reduce 1, 2, 3. Okay. Nice. So potentially the failure case is in reduce 3. So let's see. Okay. UV U cross V, UV U cross V, UP U cross P, UP U cross P, PVP cross V, PVP cross V, UV UP, UV UP, UV UP, UV UP, UV PV, UV PV, UV PV. And then this is not negative, is the same condition as it being greater than or equal to 0. This is not negative, is the same condition as this being greater than or equal to 0. This should be called underscore, just for consistency. Oh, so direction UVP is less than 0 and negative. If it is negative, then you use negative of that. Otherwise, it's positive. It's a toggle. Okay. Excuse me. Okay, so that looks good so far. UUVV. Right. So this is I'm like trying to make equivalent logic here. Okay, so if VDIS is MINDIS 2. So this is taking two values, finding the minimum of the two values, and then an if statement determines which one was the minimum. So if VDIST is the MINDIST, that would mean that VDIST is less than UDIST. So what about this stuff? So I'm like cross multiplying here. I've multiplied so I've opted to multiply instead of divide. So like the logic that I wrote is like this. So V goes here. It's times V and times U. And then this is gone. And that is my logic. I think that's equivalent because the number of U's. Wait. Oh, I got it wrong. Oh, okay. UUV divide. Okay, UU, yeah. It shouldn't matter, right? If it's all scaled. So I'm instead of dividing by V and dividing by U to get like a sort of unit P. So it's sort of unitized all the other vectors. I'm just not gonna normalize them, and we'll end up with the same number of magnitudes. So that's 2 U length, so U squared, and 2 V length, V squared. So it's like P times U squared times V squared versus P times U squared times V squared in terms of the lengths. So there's 2 U's and 2 U's and 2 V's and 2 V's. So they should be directly comparable, and it should be the same comparison. The division wasn't changing the sign either. What if there's 0? It fails if there's 0. Like it just is different if there's 0. I think that this was fine, right? So then this is like almost exactly, wait, U equals V. No, right. And then we'd never use V again down here. Okay. Yeah. We have A, B, C, and that's like V0, V1, V2. So B equals C is like V1 equals V2. P is P.U. I think this logic is correct. Yeah. What are we working on in StrafesNet? Physics system. So I have this unit test thing. No way. That actually, if I go back to here, check out comment. I have this test, and so I generate a unit cube, and then I test if the unit cube contains a point. So the unit cube is actually like the vertices are all at like 1 and like -1. So it's actually 2 units wide, and it contains the origin, the 0, 0, 0 point. I'm testing to see if this function is working. I'm converting an algorithm that does this test if a mesh contains a point, and I'm testing if it works. So if I run this test, it says it failed, and it says it failed on -z, which means that this passed, this passed, this passed, pass, fail. Phased through the wall, and when he unphased, he stayed in the wall. Huh. This is like, the algorithm isn't like, verified checkmarked yet. I haven't like said the code is correct. Jeez. So it'll cause unknown effects to the rest of the physics system because it's just returning some random crap that doesn't make any sense. So it's a garbage in, garbage out situation. So if you ask, if this is your mesh and you ask, does this mesh contain this point? And it's like, yes, it's over here. No, it doesn't contain that point. Then you've provided the wrong answer. So there's the other parts of the system that are expecting the right answer will just behave in some unknown way because it was expecting to get the right answer. Yes. Yes. I could probably harness the other stuff as well. So this one, it seems like it's generally correct. There's this one failure case. I think I'm gonna like dive into ratios and stuff, and I might find a deep bug if I do dive into that. Or maybe there's just some logic wrong. I don't know. L'UAE, UAE, MEE. Did I? Is this? Yeah, okay. So I should compare to the way that the Lua code executes. Gah. Oh, come on. Shut up. Test points. Yeah, okay. Fine. Mm-hmm. Uh-huh. 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 Lua. Does it gonna work? Rebase. No, does it not going to work? Mm-hmm. So this is how it is now, and this is how I want to be now. I actually don't need that there in this case. Isn't that like what? Isn't that what was already there? Like what? Okay. It doesn't matter. It doesn't matter. It doesn't matter. Just go next. I don't want those changes. Because it's like pre-done outside now. Okay. Blah, 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 blah. Okay, so fix it. Who did this? From Lua. Okay. Wait. Oh, is that just the Scoobert? Okay, so that was just stuff that doesn't matter. Okay. Okay. Oh. Oh, I have this function as well. Oh, fantastic. Yeah. MeshQuery. Create function. Yeah, man. Yeah, man. Yeah, man. Any mesh. Any mesh. Am I doing it right? Where's the other stuff? Well, okay, so let's add what happened? Is it trolling? Yes, it is trolling. Okay, so let's add a function mesh query trait. Why is the trait what? Oh, okay. M right? It's just M, right? We don't do like this. It's just M. Contains point M. M mesh query. Yes. Minkowski mesh is not real. Minimum difference is also M mesh query M, and it doesn't know the difference. New mesh query M is invariant. Dot mesh 0. Query P, query Q. Nah. Oh, I forgot. Okay. Wait, am I stupid? Oh no, this is query P. Okay. Okay, so now the problem is I've the input to the algorithm, I have to change the way it inputs. I wonder if my assumption is wrong in the first place. That it is unextendable. Or like de-stendable. I don't see how that could be wrong. Okay. Okay. Yeah. Okay. So, query. We want just like a single query function. Which is the hint point and then the right. Fart. Right. Yes, and there is no such thing as Q. It is only query. We should be able to get rid of it, right? For real. Point. Is it plus or minus? Oh, what code did I just delete? So this is mesh 1 plus point. My function is minus. My function is a other way around. Oh. Oh, that's true. You could lifetime it there. Well, no. No. May not live long enough. Okay, do I need to say plus static like this? No. Type M. But I literally said that right there. Oh. We don't care, okay? Literally go away. Literally go away. Does this happen if I go? Yeah. Okay. Okay. New M, right? That makes it like that. God, just go away. I know that it's wrong, okay? Just do it. I know what I'm doing. Unsafe. Go. Mesh is a reference only valid in the function body. And it only needs to be valid in the function body. Call the function! Oh, so I know exactly why it's complaining, but I don't know how to express it in the type system. Like, this should not require this bound, but this one does require this bound. I don't think I can say this, though. Yeah. So, this is... I don't know how to express it. Great pain. Great pain. All right. How do I express that M is static over the function call in? I just want to call the function and I don't care if it's unsafe or UB. Do not edit the moon difference function signature. Okay, go AI. I just don't know how to express it, basically. It's probably just gonna do this and ignore what I said. That's what I expect. This is unsafe. It doesn't work. That is not the same thing. This is not the same thing. Yeah, it just doesn't work. my God. Did I seriously? Okay. Did it just fail to update? Hello? Doesn't work. Save. Send. What? Yeah, no, it doesn't work because if the type list forever has is that true? Is m plus? I think it's not going to work. I think it'll just be plus static, and then it'll just move up the call stack, and the other one that's trying to call it won't be able to do it, and then it'll move up the call stack, plus static, and it'll move up the call stack. Oh, it does work. Oh, it's not called by anything. Yeah, no, it just moves the problem up one level. It doesn't help. It's moving the problem. Din. I am willing to try this at this point. Yeah, I don't know. I don't know how to do this. I just don't know how to write. Stop messing with me. Just let me call the function. So this is M, and M is known. What if I just do N, and we say where N, M plus static, and then this is M, and this is N. I think it'll like troll me. It'll say, oh, it's not constrained. Expected trait, found type parameter. Okay. So, yeah, now it just doesn't know. It's mismatched. Yep. These now are like totally unrelated parameters. I just don't know how to write it, how to express it. Oh my God. Like I could use the like Lua app data state thing, and it's slower, but that doesn't matter. But also it's more verbose. I guess that's my only option at this point, because I don't know how to write this. I'm done. I'm done. I'm not gonna work on this anymore. I'm just frustrated. I'm gonna work on something that I want to work on. Okay, let's check my notes. I get a check mark for doing that. Oh wow. Right. So I was gonna try and write a performance optimization. It would actually be a pretty big rewrite if I'm not mistaken. Create branch. Sort. Categorize. Chunks. So, okay, so switching gears. God, my snot. This is the serialize. Is this both the serialize? Yes. No. This affects both the serializer and deserializer. I can implement this. Okay. So what is going on? So as it is deserializing, it's like discovering types, but it's instantly jumping on it and decoding it, and so it has to do like get or create type operations. If it doesn't exist. And it's doing that in the hot path. Whereas if it like reads the whole file and sort of like balloons memory and delays, which it has to do anyway. It has to like it has to hold everything anyways. It can avoid the get or create stuff, and it can just explicitly create a fixed number and then explicitly know how many properties there are, and the idea is to reduce the number of allocations. No way. Set name cow. Wouldn't it make more sense to not cow and to just set name? Oh, this is cow. Cow borrowed. Wouldn't we get a small performance boost from this? From Lossy as ref. Right. Right. Okay, I got stuck on this. I was like got sniped by something else. Okay. I am most interested in the decoder, but it might be easier to implement on the encoder first, the serializer. Type info. So list of instances. Is it already doing this? Class descriptor. No. This might actually be a bigger rewrite than I was expecting. I just want my pull requests to be merged. That's what I want. All 15 of them. 19. Well, not this one, not that one. 19. Funny. Turn this on its head. So, isn't this an array? Why does this need to be a hash map? Insert. Okay, it's because it doesn't know what the type ID is going to say. They should be incrementing as you go through the file, but it doesn't know. Ugh. Yeah. This would be better with the slice reader and concrete types. Because then you could implement it as a slice, as a mutable reference to a slice, instead of just a generic R reader. But I guess it's fine either way. So this is actually the problem child right here. So it's using the database default properties as like a lower minimum number of properties. But if that doesn't exist, then like you're out of luck. So that's basically it, is just don't decode the chunks right away. And then we need to like partially decode the property chunks and then decode the instance chunks. Yeah, no, this is a week-long project, at least. But it might make a big performance impact. Oh, right. This only affects the deserializer. Instance builder. There should be only one reference to this. So, yeah, so we can leave the function signatures and then do the work in here or something like that, and that would work. So it would delay these. Yeah, no, it would work. It's gonna be so much work. I just don't know if it's gonna be like 4% performance improvement or it's gonna be like 70% performance improvement. Ooh, ah, ooh, ah, ooh, 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 ah. So this is our read. Yeah. I think I should base it on the other pull request, because then it has concrete types. Oh, wait. Oh, it gets dropped. Uh-oh. Uh-oh. Haha. Uh-oh. Ah. Right, but I can just kind of like undecode it. I want the efficient. Just merge my pull requests, please. We were so close. There was only 3 left, and that was one of them. Okay. So, yes, I'm gonna have to move it in and move it in, and then. Oh, interesting. Okay, interesting. Oh yeah, no, it is a getter create phase. So, do we care about this? I think we don't care about this. So who owns this data? Okay, I'm just gonna start writing code. Okay, so we want vec. And I'm gonna just instantly turn it into a vec deck. So this function renamed to like ingest. And then this is backspace, and this is backspace, and then this one is also ingest. What? Yeah, okay. So now all we care about here is these 2 things, and we're done. We just kind of yoink, yoink, and then sort it, and then done. Split at. I have to drop it after. Position. Oh dear. Yeah, Yeah, so we'll have decode as well. Surely. Yeah, man. Yeah, man. Oh my god. Yeah. Oh, is it actually a string? Oh god. Oh god. Oh god. Jeez. Okay. Okay, so that should get rid of all the errors. Expected string. Yeah. We're just gonna clone it out because, jeez, man. Actually, we could move it in, right? So we just construct this crap from the other crap. We can say prop. No. Type. It's like the data I need. The data I need. Amazing spelling. And then you just deconstruct that into these fields. And we move in, and that's great. And this is string, and this is whatever, the data I need. Why are you doing that? U32, type info, yep, something. Yep, something. Okay, so now the insane amount of underlines are gone. And we can finally get something done. Oh, wait. No, that will work because we'll into iter this. It will work. Trust. Okay. The data. The data for decode prop chunk. What is going on? Okay. Okay, what's the other one? Wait, chunk. Right. So chunk. All of it will be there, so let chunk mut u8 equals the data chunk. Yep. You know it. So actually, I think I can mutt like this, and this moves out. I do believe that is correct. Yeah. Okay. So. Right. Next, what other problems? Yeah, here. So we do not care. So we're doing this here. I hate that. Why does it change the tabs? So irritating. And we can do that here, and we can do this here. Please stop changing the tabs. Okay, so then this is gonna be the same as the other one. Can we not be there? The data I need. That is real. Okay. Yeah. Decode. Yeah. Surely. Yeah. Okay. Okay, so then what does it want? What kind of data? Instance chunk, we want boom, 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 boom. So we need an extra line here. What? Did I not copy 4 values? Oh, it's trolling me. Okay. Okay, I'll just do this right now then. Okay, number instances is a U32. Object format is a U8. Type name is a string. Type ID is a U32. For decode inst chunk to upper camel case. Okay. Oh, something like that. Outline. Okay, so it'll just not decode it. It'll just decode it a little bit. It'll just decode a little bit, you know, a little bit. Just to know a little bit about it, and then now that it knows a little bit, it can know more later. I can actually re-decode it here, and that would be simpler. Ugh. What incarnation is object format? Ah, we do not care. Okay. Oh, okay. Ooh, yeah. It shouldn't be that hard, actually. I'm actually looking forward to this. It shouldn't be that hard with this design that I have crafted. So, as you know, of course you know, I'm just gonna go and do a cursor. std io cursor new chunk as slice semicolon cursor boom 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 boom. Okay, how do you do this? The data. Okay. Type info. It's gonna be there somewhere. Great pain. Great pain. This would be much safer if the deserializer had stages instead of one big ball of state. It like as it went through. Well, no, actually, that's only applicable to the serializer. Doesn't work for the deserializer because it has to like encounter any chunk at any time. But I guess you could do that inside the finish function, or I could do that inside the finish function. Oh my god. Oh, this is going to be bad code. All right, write it. Write the bad code. Struct bad code. We know what it is. We know it. It's right here. Boom, boom, boom. Yep, this is for the inst chunk, which now has a definition. It's right here. Colon. Boom, boom. The data. Boom, boom, boom. Boom. Colon, boom, boom. Okay, we have a struct. It also needs the chunk data. Chunk. Vec probably UA. And then yeah. And then the other one is very similar. What? So no guy. Okay. Result. Right, we're gonna be pushing this into a table. Oh god. Yeah. Into, and then chunk, except we also need to mud it. Chunk dot, how do you drop? Split. So I want to split off, but drop. I do not care about part of it. Truncate. It's truncate. Truncate. Yeah. So I'm truncating, except. Oh Jesus. Is there? Yeah. I need to truncate the other from the other side. I want to keep the last len elements. Rust vec deck truncate front. Ew. Nightly method truncate front. September 4th. Really? Standard library doesn't have this? Bro. Well, it doesn't really matter. It actually doesn't matter. Actually. To do. Use vec-dec and truncate front when it's stable. Okay, so standard library is letting me down for a second time. That's crazy. Cursor.position. Size. Keeping the last len elements. Okay. It is borrowed. Ah, true. Rest. Okay. Yeah, I'm just gonna go here and we'll use a vec. So apparently you can't do what I wanted to do in the standard library. Nice. Data for, who knows? Prop chunk. Prop. Yeah, so we're gonna slice this from something, who knows? Okay, 4. We actually need to record the cursor pause. That's brutal. So you need this for both. Okay. Okay. Right. Okay. Yeah. Actually, I can make a little function just to like make it suck slightly less. Oh, it's right here. Okay. 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 What do you want? Borrow occurs here. That's a great pain. Yeah, I don't think I can actually do this. Okay, fine. Fine. We do not care. There you go. Okay, so now we grab the stupid properties from this stupid one and make it stupid. Let's go stupid. Boom, boom, boom. Yep, actually that is the whole thing, isn't it? Huge. Okay. Apparently we need a lifetime. Let's go. What do you want? Okay. Yep. So we actually can just grab this after. We'll probably need to mud it here or something, but whatever. Cool, no more lifetime. Program computers, holy smokes. Okay, cursor, position. Okay, yeah. So we're doing the same kind of crap here. Yeah. Yeah, prop man and prop name. That should do it. Okay. So actually, this does not need to be public at all. Where is the other one? Decode, ingest. Why? Oh, yeah, so decode should be private here. Cool. I don't know why it's trolling. Okay. Worked on it. Okay. So now, something will happen, definitely. Ugh. So finish that at the bottom, right? Yeah. Okay. So, So it doesn't need to write it. It's a freaking. It's fine. Okay. So we gain ownership here, so we can actually destroy the whole thing. Ooh, ah. I'm not feeling it. Let me go look at the bot files. I'll just leave this as is. Okay, so the bot file doesn't decode properly. Bot file. One is wrong, and it's gonna be annoying to figure out which one it is. So I have to write tests. All the fields are public, so I can just do it. How do I figure it out? Wait, BW ignore. Wait, is that it? Temp. Is this? Is invalid without ignore? I'm every woman. Let's go. So, calc. What is calc? Expected equals, yeah. Okay, what is calc? BW. RW calc. Okay. Calc. Where's the search? Can I go to the latest? Is this the latest version? Isn't it on like 17 or something? Ah, jeez. Okay, if I go like this. Why is it so hard to search? Quick links, please. Oh my god. Okay. Computes the field of value instead of reading data using a field. Okay. EXPR. So I can literally just like smash it in, right? Okay. What? read, write. Can I? Jeez. Okay, temp is only BR. Jeez. Oh. I'm wondering if this is the problem. I imagine that is the problem. $81. $81? Okay, I need it like this. Okay, there's only two. Okay. That might have been the problem. Let's see. Fix bin rate. Yeah. Roblox bot file test. It didn't work. Or maybe it did, and I just don't know it yet. Find which data. So I'm comparing data to file. Okay. Okay. So I want to check this first. So I think it should work. Oh, it doesn't work. Dang. 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 Dang, I thought that was it. It might. Because, like, BW ignore. I don't know. I just don't know. Let me test it. It's gonna troll me. Or no, it's not. God, it is gonna troll me. Okay. Drop. Okay. Okay, let's write some goddamn tests. Okay, it should be easy. I just go like test function. I don't care. Run it. World event button. Snake. button ID 73 magic. Oh, it doesn't exist. Okay, dot write lee to mut data. Unwrap. Okay, and then we do let button equals to this guy data dot readly readle as slice readly. Do I need a freaking trait? Is it like, I don't know. What the hell is going on? Okay, it needs seek. Okay. 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 Oh, IO. There is no core IO. STD. IO. Cursor. New. Data is slice. Cursor. Readly. Unwrap. Data. Seek is not satisfied. Okay. Cursor. Seek. Oh. Can it fail? Yeah, okay. Is there like a special cursor seek? Oh, set position. Oh, let's go. Okay, and then we read it again, and now we have button, and then we go assert. Button ID equals this guy. Input button ID. And then output. Jeez. Okay. Oh. Okay, that was very annoying to write. Okay, so it's it passed. No. What? Why is that on bin write and this is on bin reader ext? Okay. So it passes the test. Meaning that's not the problem? How do we write a U32? Oh, I know how to do it. Amazing. Okay, so then we can use this, and then we can interpret the data as a string, I guess. And then yep. All right, let's see. Okay, so it is actually cool quat data. So it's not failing to write this. Okay. Well, I thought that would be it, but it was not it. I'm gonna go like cook something. I'm gonna put something in there. It's only been 2 hours. Oh my god. I've hip hopped to so many different projects in so little time. Do this first. I bring cheese from the great cheese hole. Oh. I need to find something that would fail a test like this, where I write the data and then try to read it and it's different. I need to figure out why. Basically, I have a thing going on. So where is this branch? Right here. Okay, so I recorded what the block timelines are when it's just read out of the thingamabob. And I put it in a big ball of timelines, and I run a new algorithm to construct a new set of blocks as if I am writing a new bot file using the complete list of all timelines. And the blocks that it generates are different. And I don't know why. I don't know if it's very clearly actually generating an invalid file. And I think that it's a serialization issue where it just isn't writing enough data, because like it's falling behind here. It's not, some of the events are like incomplete. It's like writing not enough data for some reason. That's why I thought it was the magic there. That would explain it. Okay, what if I check the read head? That's a good idea. That's a very good idea. Web test, whatever, it doesn't matter. Okay, so if we go into this, oh dear, I'm cutting cheese. Okay, I'm gonna write it down. So it's my idea is to check the amount of data that was written every time an event is written. Period. Okay, so now I can cut my cheese. Okay. I forget these things so fast. Gotta write it down. Alright, I'm just not in the mood to hear this music. Not in the mood. That's a bad phrasing. Okay. The cheese. The cheese. Yes, the cheese. Okay. That's the cheese. Next up, the algorithm. The cheese, the algorithm. Good. Damn, that was a miss. Okay. Okay. Cheese success. Man, that's good cheese. It's Gouda. Mild. So simple. So good. Okay, what did I write? Amount of data the art was written. Me too. Amount of data the art was written. Yeah. So let's see. Here. Okay. So this is the check. Pos equals to writer dot position. I guess we can just question mark it. And then assert. Pause end minus pause start. Event size, event type ID, semicolon. Event type gabagoo, and you need debug. Okay. U64. Okay, sure, whatever. As U64. Or we can do as U size actually. No, as U64 would be easier. Okay. What do you want? No debug. At least debug, man. Okay, here we go. Test release. It should just fire it off. Failed. Woo! Event type world. Good job, me. Okay, so 96. What? 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 World event. Mm-hmm. So we expected 24. Isn't that like totally wrong? In all cases? Eh? It should be 12. Oh. No. Oh, U32. Okay. That's freaking 16, man. $24? What? Right. Oh, okay. So F32, uh, the discriminant vector 3. That makes perfect sense. 24. It's 24. That makes sense. But then we go and 96 was written. Okay. Oh, it's a range. Okay. Okay. Oops. Haha. Oops. Haha. Lol. Okay. Times num events. Okay. Lol. I just did the check wrong. Whoa. None of them were wrong? Okay, so something else is going on. That's event chunk header. Hoo he hoo ha ha. Is that the problem? Num events, read data into events, chunk header. No, that data isn't the chunk header. T. Okay. I don't get it. I don't get it. How's it wrong? So every single slice of events written was written correctly. According to the sizes. Three world events. Interesting. Well, there's not a lot of places this can go wrong. Okay. Okay. Let's try the timelines. It should be correct, shouldn't it? I should be able to do this. Boom, boom. And then assert. Same garbage. File header dot blah, 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 dot len is equal to blah, 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 blah. Block timelines. Come on. All right, go for it, champ. Okay, so yeah, it passes. Duh, it's super right. How else file go wrong? Why file write, not same file read? I see B-hop. Oh, I want to see some B-hop. I'm making a B-hop game engine from scratch, which is pretty cool. I'm currently working on the file decoder. Oops. For a different game, actually. I also made a B-hop game on Roblox. Oh, that's a physics bug. We're doing the same? Really? So it just breaks. I can rebuild it in a different version. Strict client. Oh, I forgot I was running AI. Good thing it doesn't use a lot of VRAM. I think it's using like 64 megabytes of VRAM. I'm trying to make it so you stop falling through the ground in the game, and so yeah, it's been my goal for this year, and I'm still working on it. But I have done a lot of things this year. Does this stream start lagging if I go full screen? Oh. What? 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 Okay, well, that was a window manager thing. What language are you using? Rust. I picked Rust because I knew that I would write a bunch of memory leaks if I wrote C++. And that was pretty much my only reason. I was like, oh, cool, memory safe. And it's supposed to be fast. And I knew that the ecosystem for game engines was not nearly as mature as C++. But when I wrote my Roblox game, I didn't use any libraries by anyone else. And so I figured, like, well, if I already don't use any libraries, it doesn't really matter if the ecosystem isn't mature. I'll just make everything myself. And so far, So good. I just have the bar set so high for the physics. I'm using fixed point numbers for the physics. So there's no floating point numbers at all in the entire physics, which you wouldn't be able to find libraries that do that. So all custom physics. Yeah. The same. Really? You mean like libraries? If you want solid collisions, no floats. Really? Determinism, for sure. All right, you've reassured me. I thought you were trolling. Like, oh yeah, I'm doing the same thing as you. Down to the physics engine. Oops. Ugh. So it works quite well, but like there's some strange edge cases that are due to the janky way that I'm setting up the physics. So I am doing parabolic mesh tracing for my physics. That's not going to work. So I have an algorithm that is doing that. And what it's doing is it's crawling over the surface of a mesh. No convex hulls. Yes, it does. It implicitly assumes that the input is convex meshes. So it's like tracing one mesh onto another mesh. How it works is it's tracing the closest point on one mesh to the other mesh across the surface. So it needs to set up to do that, right? So like as you move through space, I have props here. Let's do this one. Okay, so let's say this is your hitbox and this is the platform. You don't collide AABB, just mesh. Yes, I actually started with axis aligned bounding boxes and that worked great. Great. Didn't even know that was the thing. It's definitely about 600 times more complicated. Okay, so I have a starting position of the meshes, and I want to see if in 1 second they'll hit. I guess it doesn't matter the time. It just matters at what time will the meshes hit. Excuse me. So at the starting point, you have some initial condition where the closest point is like here on the face, right? And then you trace it out. And then once the closest points intersect, you found a collision. But how do you get that starting point? And turns out that's pretty hard when you're doing two meshes like that. So I just came up with some jank 2 years ago that does that. And the jank version is instead of like starting here and you go like this, you start infinitely far away. And what's the closest point to something infinitely far away? Well, that's a little bit easier, right? You just kind of like, what's the farthest vertex in that direction? And then like, it's going to be somewhere around there. And then you like trace it in from infinity. Here it comes. And you like So it's like, oh, okay, here. And then now you have your starting point. And that's kind of like a waste of computing power and stuff. But like that was the jank that I came up with 2 years ago. But I've discovered that I actually have an equivalent algorithm that just does exactly what I need. And so that's great. So all of my physics code is generic across mesh types. How do I say this? Physics. So I have this trait called MeshQuery. So a trait is just like a collection of functions. So you can say like, this object implements this trait, meaning you can call this function on it, you can call that function on it, and it'll have its own little implementation of each of those functions. So the MeshQuery trait is implemented for physics mesh view, which is the most low-level version of the mesh. The physics mesh can have multiple sub-meshes, and each sub-mesh is a convex mesh. So you need to like have a view into the mesh because of Rust's ownership and borrowing rules. So there's that one. And then I have a transformed mesh, and that is, so the physics meshes are like deduplicated, right? And then you would have a transformation for an instance of that mesh. And you'd say, draw one of them over here, draw one of them over here. So that's the transformed mesh. And then also there's Minkowski mesh. So this one is a little bit different. It's a sum of two meshes. And the idea behind that is to make it so that I can use algorithms that only work on a single mesh on two meshes at once. And that would turn, like, if I was tracing a ray onto one mesh, if I use a Minkowski mesh in place of the mesh in the algorithm, that's equivalent to tracing a ray of two meshes. So it's a very useful tool to be generic and extend the usefulness of your algorithms. This Minkowski sum, and the Minkowski sum is conceptually not that difficult to imagine. So imagine inside of this mesh the center point. And imagine the center point, if I keep both rotations fixed, if I'm tracing out this mesh on top of that mesh, it's tracing out a surface. The center point inside of this is tracing out a new surface. And that surface is the Minkowski sum of the two meshes. Minkowskis are expensive. My trick is that I don't compute the full Minkowski sum. I am, so we have this little trait guy. Where's the trait guy? So we have the MeshQuery trait. And so I can query what are the edges beside this, around this face? What are the faces beside this edge? What are the vertices of this edge? So I have these like queries to explore the topology of the mesh. And so that's all I need, right? Because I'm like walking across the surface of the mesh. So it is quite complicated. Each of these functions took me a long time to write. And so I'm like going through the cases of the Minkowski stuff. So you can see we have a Minkowski vert. That's always a vert and a vert. So it like takes a vertex on this mesh and a vertex on this mesh, and it pairs them up, and that's a Minkowski vert. And then same for the edge, except now there's two cases. There's a case where like you are, if you imagine the center point of this, tracing out an edge, we're on the edge of this mesh and the point of this mesh. So it's like, this is a Minkowski edge. But there's also this type of edge where it's a point on this mesh, but then an edge of this mesh. So there's two different ways you can represent this Minkowski edge. And then similarly for the face, there's three ways you can represent the face. You can have like two edges, or you can have a face and a vert, or a vert and a face. So I've implemented all of the cases to do the mesh queries for the Minkowski sum. So the idea is that I don't have to calculate the complete Minkowski sum, and I can like just do what I need as I'm crawling across. But like multiply that by my wacky fixed point numbers, multiply that by my wacky crawling from infinity algorithm to initialize it, and it's like, it's slow. And like the saving grace, and the reason why this can run at 1000 FPS in 4K is because it does so little work. So it knows when it doesn't have to do anything. I'm cozy and warm for long-term bug housings. Yes, this is 2 years ago I wrote it, and it's still giving me bugs. You're exactly right. So like, look at this. So I'm standing on this surface, and as I get close to the edge, oh, not that side. Okay, close to this edge, I fall off. So that has to do with the Minkowski sum. So like, remember the face. The face definition, you can have a vert face. You can also have a face vert. So a vert face, that's like vertex here, face here. So that's like, that's a Minkowski vert face. But then you can also have a face vert. So that's like face here, vert here. Right. So when I'm standing on the face, it remembers which Minkowski face I'm standing on. So if I'm standing over here, that's probably like this, like face vert. And I can like walk across. Uh-oh, but we've reached the edge of the Minkowski face, and it has to be able to switch over to this representation to be able to walk across the edge and like overhang, but it doesn't work. It kind of just falls off because it's like, uh-oh, I fell off the edge, and it just kind of falls off before it doesn't work. So that's one of the bugs. The bug that I'm working on right now is, where are we? Okay, we go over here. No, this way. Oh, I have cylinders. Yes, that was a pain. Did these ones work? I don't know, it doesn't matter. Okay, I know that the bug happens over here. This is where the bug happens. So when you touch things simultaneously, it can break. Did I fix that though? Right. Right, it has to do with the setup. Right. So look, I touched the edge of that. I just went right through. But if I don't touch the box, it's fine. So I thought it was like an edge case of like axis alignment, and then like crawling across the surface when the direction you're moving is like exactly parallel. But it's not that. It doesn't fail in that case. It's actually I think because of the Minkowski faces, the same sort of bug. So if you imagine these are the same size, it's like it's like contacting like this. So then it's as you're like falling, it reaches the bottom of the representation, and you stop touching this object at the same time as you start touching the trigger on the floor, and that like upsets the engine and it skips one of the events because it can't figure out that you start touching something in 0 time. And that's because of the algorithmic setup where like it's coming in from infinity. That algorithm is janky, and if you're actually exactly touching it, it doesn't work. The setup doesn't work. So complicated. So I discovered that I have this new algorithm. Oh, did I change the code? Yes. Not new algorithm. I discovered that I had this algorithm already in my game on Roblox. Thank God you're not using floats. Yeah, I want it to be exact. I am going to extraordinary lengths to like never double cover the physics. So like how most physics engines work is like they're sort of corrective, where like you run one game tick and it teleports you ahead and then checks if you're intersecting anything, and then it teleports you to the next game tick and it checks if you're intersecting anything, and then it teleports into the next game tick. Intersection, and then it pushes you out and it corrects the position. No. My physics is predictive. So I am tracing the path volume of the meshes. There's no such thing as game ticks. It just kind of like is catching up to real time. There's no fixed tick rate. Deep penetration is awful. Quit Godot. Damn. Yeah, like, so I'm like finding the time of intersection. It's like, okay, this object is going to pass through this volume in the time, the like time range that we're trying to advance. It's going to pass through this volume. Okay, well, it hits this object at this time. So we're going to advance time to exactly that moment, handle the collision, and then continue until we reach the end of the time range. So if this is going to hit like 5 different objects in one step, it'll just do that. It'll hit the first one, hit the second one, hit the third one, hit the fourth one. There's no limit. It's like I can show you the code. It's like it has this loop. The loop. Is it in here? Common source instruction emitter. Yeah, it's this one. It reflects your velocity instead of sliding you along the surface. Bounce? For everything? Every object is bouncy? I don't see how that would work. Ugh. vector reflect. I'm projecting the vector onto the contact normal, the plane. Okay, so this is the entire algorithm that I just described. It's called process exhaustive. So this is the physics internal state, and it asks itself what's going to happen next. So that's like in the time range, time limit, the current time up to the time limit, what's going to happen next. And it'll like look through everything that's going to happen and return the soonest thing that's going to happen, the next thing that's going to happen. And then now it knows what's going to happen next. It does it. Loop. What's going to happen next? Do it. What's going to happen next? Do it. What's going to happen next? Do it. So this is an optional value. So it'll be option none if nothing happens within the time limit, and then the loop ends. So there's no fixed tick rate. Wow. B-hop. So you're doing like Quake B-hop and not like CSS B-hop. So is it like half sideways? Sure, unique. My goal is to make it, I'm like designing the entire game engine around B-hop rather than like, rather than like using an existing game engine and just kind of like winging it. I'm thinking like, what is the best possible physics implementation for a speedrun game like this? And I think it's this like predictive physics with tickless physics. No fixed tick rate. So like every time you have a game input and you like every time you like press a key, it's like, oh, there was an input. We have to advance time to that input. And then whenever there's a game frame, it's like, oh, we have to advance time so that we can render this frame. And those are the only things that need updates. So like if I just jump and take my hands off, that is an analytic continuation of the current state. It doesn't actually update the game state while you're in this analytic state. So there's analytic state continuation and atomic state updates. It's my pristine ideas. Merge all Quakes into a path of exile like tree? You pick the physics as RPG skills. That's crazy. What the heck? That's interesting. Oh, my dinner's ready. I'll go check it out. I'm not done my cheese yet. Oh, it smells good. very interesting ideas. Real smart. I've kind of coded myself into a corner, right? Where I'm putting my best ideas forward, and then I'm not smart enough to debug it, as you do. But yeah, that's like what I think is the best physics for like a skilled movement game. To have this predictive physics system rather than a corrective physics system. And like, how do you design the game engine to immediately respond to the inputs and like not depend on the graphics and stuff? Where else is this? Process exhaustive. Let's go to the implementations. Mouse interpolator. Oh my god, that's a whole rant. Session. Right, I did that crazy. Okay, so next instruction internal. There it is. So Rust has this idea of mutable references and immutable references, where if I'm using these immutable references, it's just a view of the data, and I can't mutate the data. I can't change any of the data. And I just love that so much, where I'm asking what the next instruction is, so I should only be allowed to see the current physics state and not change the physics state. Asking what happens next shouldn't change the internal state, right? So I have this instruction collector, and collect. Oh yeah, collect. So it's like, we have our time limit, right? We're exploring a time range to find out what happens next. The collector collects events that can happen and returns the soonest one. I guess it's actually pretty simple, right? Collect. So if the instruction exists, if it's not a none instruction, then, and the time is less than the current best time, then set the time, do the time. Did I make the time? Oh, right, I do have it. Okay, so update the time to the new best time and set the instruction to the new best instruction. So just returning whatever the best instruction is. Where was I? Physics. So the move instruction is the strafe ticks. Oh, is it also water? No, there is no water. So move state air, next tick. Oh, this is, I forgot. I had a strategy for this to make it work with 0 time events. Immutable data is bliss. What was the quote? Oh yeah, it's if you, you are by definition not smart enough to debug them. It's like debugging is 2 times harder than programming. So if you use all your cleverness in programming, you are by definition not smart enough to debug it. Something close to that. So yeah, there's no fixed tick rate, but the strafe ticks do have a fixed tick rate. So it's sort of interlacing the strafe ticks with the happenings in the world and with your inputs. It has to produce a global order for the external inputs, the internal physics events of like you hit a wall, you stopped touching the surface, and then the strafe ticks that is at a fixed tick rate. So one of these internal events is right here. It's walk. What is it called? Reach walk target velocity. So that's not too complicated. That's like if I press W and I reach my top speed, I've reached my top speed. But it's also I've reached 0 if I stop pressing W. So like you can see how that fits into the like analytic state continuation, where when you press W, it enters a accelerating state, and then you have an analytic state continuation while you're accelerating, and then it knows that the next instruction at some point will be you reaching the top speed, and then you reach the top speed, and now you're at a constant speed, and then there's no new instructions. It's very it's really easy to mess up the timestamps and time travel, and then you get like stuttering and stuff. Yeah. Love the concept. I'm so sorry. You might have to rewrite your game now. You can't get it out of your head. It's like so complicated too. But it's the best. It's the best ideas I had. You know what? Why don't I fix the tick rate right now? Let's see. So I'm wondering if it. No. Okay, no. Okay, next tick. So, self strafe settings. Self. Yeah, I need a tick state. I'm just gonna write it. Okay, so here's what I'm thinking. There is strafe ticks at a fixed tick rate, right? So if you're asking when the next strafe tick is, how do you know? Well, you can just round time, right? You can just go, oh, this is gross, but modulo, right? You just modulo time, and that's when the next one is. But what if you are at that time? Well, you need to have an internal counter of how many strafe ticks you've done, so that if you go up to that time and then do a strafe tick, and then an event is supposed to happen on that game tick at that timestamp in 0 seconds, like you had a strafe tick right as you're about to hit a wall. How do you know that the strafe tick has already been completed? Well, you have to have the internal counter. And I don't have that right now. So I can't have these 0 time events and guarantee that I do exactly one strafe tick. So that's what I'm going to introduce. I'm going to give it a little internal state. Self? Is that self? No. Move state. Move state. Fly. Water. Water is not real. I haven't implemented water. Okay, where's physics state? Physics state. State. Move state. Does the strafe tick state go into the move state? That might be a bit more complicated than I thought. I'll go get food. Got distracted. Yes. I think it does go in the move state. I'm gonna have to decide. Oh, Bubba. Walk, ladder, air. Yo, okay. What's here? Style helper, style mod. There's a trait? Ew. Okay. So strafing only happens when you're in the air. Yeah. Okay. Let's do it. Struct strafe tick state. Tick number. And then when you're in the air, you have strafe tick state. And now all of the red underlines get updated as I change my data model. Hello. I found a chatter who's making a B-hop game for Quake. And they're like using fixed point numbers as well. Holy. Competition. What's Quake? Okay, so this is underscore. Apply input. Get walk state. Nah. So next move instruction, this is where it comes into play. What's that? Option strafe settings as ref. Yeah. So this is the strafe tick states. Strafe tick state. What is it? Move input? I don't know. Strafe tick, whatever. Strafe tick state. Yes, and it's immutable. Next tick. So this would be dead simple. Boom. Dead simple. Dead simple. Next tick. Should be dead simple. Next tick. Ooh. Yeah. Okay. Yeah. And then use the strafe. Yes. Perfect. Strong types go hard. Okay. Implement strafe tick settings. Function next tick. Settings. Strafe tick settings. Strafe settings. Style settings. And we return time inner? Is it a time inner? Or is it a time inner? Time? Yeah, okay. Not entirely convinced. Yeah, okay. Dead simple, he said confidently. Ooh. Dead simple, he said confidently. Okay, what was the old function? The old function was this one. Next tick. All right. Oh no, I don't need that actually. Tick rate. Oh yeah, that's right. Oh me. I think I'm gonna end up with ratio time no matter what. Haven't we heard this song? So it actually shouldn't depend on the current time. Okay. It just goes like tick number times tick rate. And tick rate is ticks per second. It's a ratio. Is this stuff? Mul int? No. 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 Mushrooms are so good. This is stupid. I should delete that. Okay, I'm just gonna do it normally. So oh, self, obviously. Self. Tick number as U28. Per second. Ticks divided by seconds. Settings. Tick rate, no numerator. I don't know. Okay, and then seconds equals settings, tick rate, denominator. And then you do, what time is the strafe tick at? Well, it's the tick number times seconds divided by the number of ticks per second. And that's it. And this is always guaranteed to be 64 biddies until you get with the really big biddies. Pain. Okay. Yeah. Time. There's no more +1. So, how many ticks per second? Well, yeah, this makes sense, right? Seconds divided by ticks. And like, this is a freaking ratio, but like, whatever. We'll just not do it like that. Okay, next tick is done. No way. So that is all that there was to it. So now set move state. Error. Set move state error. Error. Haha. Yes. Walk state. Haha. Yes. Style dot strafe. We need to pass the strafe settings into a move state constructor and like figure out how many strafe ticks the current time is. Oh yeah, no, I need the time as well, don't I? Who has the time? Does the move state have the time? Input state. This doesn't depend on time. Pain. I should not finish that cheese. Mousse air, yeah. Yeah. We can insert this in most of these. So mousse there. Air. We need to build it. Set mousse there. Yeah. Yeah. So we need to know the current time. Oh, body has time, right? Is the body? The only time that matters is the physics time. It only matters in the constructor. Yeah. Okay, so let's go to definition. So we need a freaking air constructor. Function air. And it returns self. So time is time. And settings is strafe settings. Style strafe settings. Oh, so we go, so the opposite of this, we're calculating the tick number from the time. So we go, oh, this is optional, isn't it? Yeah. Good. Wait. This could become a disaster. It's okay. Move state air. Tick number. And then all we have to do is set tick number equals something. I guess if let some settings equals settings, then the calculation is, give me that. So time is this. Time is time. Time is time. Okay. So to get n, you multiply by ticks and divide by seconds. Wow. Time times ticks divided by seconds. No way. As U64. And that'll do them. Else 0. Beautiful code. Okay. Yeah. That's definitely right. Definitely, yes, definitely right. So something I couldn't do before. Oh, this doesn't need time. Fascinating. Option strafe settings. Let's do it like this for lols. As ref. And then time. What time? What do you mean time? So you need to know the current time to do this. Time. If you want to call it, this is just a stupid function in the first place. Okay. Okay. Time 0. Yeah. None. Okay. Yeah. Next move instruction does not need time. Very amazing. Call velocity. It does need time. Oh, true. Strafe as ref. Bug putting up a fight. I am doing something else. I've been working on this the bug I was talking about for a year, so probably not gonna get done today. I'm hoping to fix it by the end of the year. Did I pass the style? Yeah, okay. Next. So I'm currently doing the internal tick state, where if it arrives exactly at a strafe tick, it can do the strafe tick and then remember it's already done the strafe tick. If it needs to do another 0 time event, so that if things happen at the same time, it can like do them in any order, kind of, but hopefully there's a deterministic order. And it won't try to do them again and end up in an infinite loop. Time. Do I have time? I have time. Okay, next. Time. Definitely time. Yes, time. Let's go time. We get time. Okay, I've always got time. Okay, move state air time and style. Yep, dot strafe as ref. Let's go. There's no time. Yeah. Okay. Time. Next. Good Lord. What is happening in here? Oh, goodness gravy. That was the one thing that didn't need time. Time? Is it state.time? Yes, it is. Okay. Call velocity, time. This function also causes me a lot of problems. It's poorly designed, it's poorly thought out. So if you have unit tests for all of this, they'd be a real lifesaver. They would, wouldn't they? Time style. Uh-oh. Do we not have that here? Physics state. Oh, we do. It's in the state. Or is it in the data? No, it's in the state. State dot style dot as dot strafe dot as ref. Time. Okay, state dot time. And one more. Same dude. Pew. And state that time. Okay, the red underlines are going away. time. We got time. Yay! Red underlines. Yay! What is this complaining about? MeshQuery hit point. Yeah, okay. I can just say expect dead code. And then I'll remove it when it's done. Expect dead code. Okay, so I just implemented strafe tick with internal state. So previously the strafe ticks were stateless. So it would just try to determine what the next strafe tick is from the current time. So if you were before the strafe tick, it would go like, oh, there's a strafe tick here. If you were at the strafe tick, it would go, no, next strafe tick is here. So it kind of like give the ceiling of the regular strafe ticks, but that's not quite right, because you can arrive at a timestamp without running the strafe tick. You can arrive at the exact timestamp of the strafe tick due to something else. It handles something else, and then now you've skipped the strafe tick. So it has to know whether you've done that strafe tick yet in order to properly handle simultaneous events. Sounds like a big no. I do actually have some unit tests, but I find them, I've sort of done them at a high level. So I have these like test collision things, and I'm just like, I have two meshes and they go like this. What's the time of collision? And it goes, but like all of the inner stuff of the physics, the functions that the Minkowski sum is using, like, here's the Goober algorithm. To do, fundamentally improve this algorithm. This is the trace from infinity algorithm here. So we go infinity to infinity fev, crawl from infinity. And it expects to not hit it because it's like the setup for the algorithm. So it finds the closest face, edge, or vertex at that time. That's fev. So there is tests, but like I'm only really testing at a high level. It doesn't test the individual functions extensively. Okay, so I actually implemented a new feature here. Like I was talking about. Okay, right. I was looking at this. Gameplay style next tick is not real. We don't use that function anymore. No. We do not. This is the strafing. It looks stupid because air acceleration is optional, and I'm using my fixed point library. Oh, I didn't mention the fixed point library. It every time you multiply two numbers, the bit width increases, and that's determined at compile time. So it will never overflow. But also, if you multiply too much, bad things happen. So you can see this is like fixed 1 wide, and then say widen, and now it's a fixed 2 wide. Wow. This everything in here is like crazy overkill, but like it's the dream game engine, right? So if I'm not dreaming, like what am I doing? Physics time, okay, not used. Okay, okay. Let's see if it works. I added a new feature. Strafe tick state, tick number. So whenever you ask what the next tick is, it's purely calculated from the tick number and your tick settings, your tick rate. So like 66 ticks per second, it'll go, oh, if this is tick number 67, the next tick is 68. Oh, whoa! I didn't update the tick number. Hold on. It would it would enter an infinite loop if I ran it right now. Okay, we need to find the mutable state. Okay, next move instruction right here. Next move instruction. Next move instruction. So this is finding what the next instruction is. This is applying the instruction. So process instruction, do this. So the internal instruction, maybe you start hitting something, maybe you stop hitting something, maybe you're doing a strafe tick, maybe you are reaching your walk target velocity. Those are all the internal things that can just kind of happen over time. And then there's also the external things. So this is mouse input. This is you're changing something idle. Idle is basically rendering a frame. You're like idling the physics up until a certain time so that it's up to date. Very cool. Okay, internal instruction. That should be right here. Strafe tick advanced body instruction. Strafe tick. Ooh, call velocity. Ayer. Okay, so we have a mutable reference to move state. Okay, reach walk target velocity. Okay, I see. Yeah. So strafe ticks only happen when you're in the air. Make this less huge. Okay, so air, strafe, tick, state. So if it is this enum variant, why did it untab, man? Z-editor just absolutely messes with your tabs. Okay, and then I want to go, if it's something else, this is, I'm printing instead of panicking. This should probably be a panic. Whatever. So this is a similar thing. So if you're in any other state and it's trying to do a strafe tick, something has gone terribly wrong. Emacs is better. Let's see. Strafe tick fired for non-air move state. No way. So we have strafe tick state. So this you know what? I am going to make the line numbers small. Okay, strafe tick state. Strafe settings activates controls. State call velocity. What? Tick velocity. So this is actually changing the velocity. Why is this let sum ticked velocity? Why is this an optional value? D less than MV. Okay, so it's like if the velocity did not change. Okay. Where was I? Physics. Okay, so at this point we are doing a strafe tick. No, at this point we are doing a strafe tick, and we do strafe tick state dot tick number plus equals 1. Okay. It doesn't matter. That's cool. Okay. Okay. Build it again. It was wrong. Are you scripting Surf and VOP or developing? I'm programming. All right. Surely this doesn't just crash, right? What map should I go on? ISO is cool. Okay, so far so good. I'm not in the air yet. So once I go in the air, it'll start trying to run strafe ticks, and it will lag the game. I just... Wait. No, it won't. No, it won't. The type, oops, the type safety saved me. I accidentally didn't write a bug because I'm writing it in Rust. Wow. Okay. Wow. Nice. Dang, it just works. Let's go. This is the Rust experience. New feature? Just get rid of all the compile errors and then it just works. Sometimes. But a lot more than other programming languages, that's for sure. Wow. Okay, so now the strafe ticks can handle 0 time events. So you can land exactly at the moment when the strafe tick occurs, run the strafe tick, and then run some other event, or the other order. Run some other event, and then, oh, I need the strafe tick. Run a strafe tick, and then it won't run any duplicate events, duplicate strafe ticks. It won't like skip or duplicate the strafe ticks. I'm kind of surprised that I didn't figure this out 2 years ago because it seems obvious to me right now. Wow, okay, so we can actually run non-integer tick rates now. Previously, it would crash the game, and I didn't realize that this was why, or I didn't think hard enough about it to fix it. Cool. I want to try that. Let's do like 10,000 tick rate. 6,000, 60,000, just because we can. Wait, would that lag? It might lag. Haha. I'm just like imagining it lagging. So something interesting. You can see that the frame rate is 2,600 in the top left. And I said that the game runs for every input. Yeah, and that's no lie. So the mouse polling rate is 1,000. You can see that the FPS drops when I move the mouse. I believe that's due to running 1,000, running one tick for each mouse input. So it's running like 3,500 game updates per okay, I don't feel like doing that again. Per second. So it's pretty fast, but we'll see if I can run like 10,000. I think I've done it before. All right, I'm gonna do it. Do you do this full time? So full time sort of implies jobness, and I am very much unemployed, but I make enough money to just do it all the time, and I really like doing it. So in terms of the pure words, yes, all the time. I'm doing this all the time, but I'm not doing it as a job. Past you is dumber. It always feels the other way around. It always feels like, man, I'll never make a physics engine again. Oh, man. And I just invent something on the spot. I'm like, oh, actually, I'm not stupid. Okay, so add strafe tick state to allow 0 time strafe events. Bow, bow, bow. Huge new feature. Tiny new feature. So it turns out that air has associated state. So while you're in the air, you're running strafe ticks, but strafe ticks are irrelevant while you're walking and irrelevant while you're on a ladder. I will probably add them to water, and they're irrelevant while you're flying. So the state simply does not exist while you are in the other variants of the enum. And so it's inaccessible and irrelevant, which is amazing. Rust enums are amazing. It doesn't say how big it is. I want to know the size. No drop, bruh. This is 8 bytes. This is, who knows? Jump direction, no drop, bruh. It's because I have the weird inner thing. Does Surf and Bebop produce all the income? No, I do have another game. It's about half. But before that game existed, I did live on Bebop and Surf for a long time. Awesome new feature. Yeah. Okay. Let's change the tick rate. Tick rate. So Neo. Who cares about Neo? Roblox bhop. Tick rate. Strafe settings. 100 ticks per second. Let's do 10,000 ticks per second for lulz. And see what happens. Is your other game on Roblox? Yeah, there's 2 Roblox games. There's all my eggs in one basket. I should have been eating. Lol. Oh, it just is chilling. Huh. Okay. So now I can go like... Did that work? I should be gaining speed like crazy. It kind of seems like the gain is less. Did I get the ratio wrong? Is it like inverted or something? I don't know. Okay. Regardless, if we do source bhop with source surf with 66 tick, sick tick, sick. It used to crash, and let's see if it still crashes. Actually, we could just keep doing this one. We can just say 66 tick. 66 tick. Okay. Tick. Default is Roblox bhop. You have to rebuild the game to change styles. So it doesn't crash. It used to just crash. Okay. Okay, I'm going to set it to 1 tick per second and see if it's 1 tick per second. Okay, I need to heat this up now. Oh, it's good. Hey Sokam, do you stream your work? All right, let's see. Is it 1 tick per second? No, it is very much not 1 tick per second. Something is not right. It looks like I'm gaining like. It looks like it has no effect. Had to restart 2 times? Me too. I rewrote the project 3 times, I think. I think I'm winning. But I have been going for 2 years. I ran out of money in the middle of the project, and it kind of killed my my vibes. But that's when I made the second game, where I said I was making money from 2 Roblox games, and that solved all my financial problems. I'm so lucky. So I just get to work on this again. Okay, I have no idea why it's not like reading the style settings. And like what we should see is it should go like instead of being like smooth. Got a job, burned out. There's a lot of life that can happen when you're trying to make a game engine. Okay, where's the damn move state? Okay, so what did I write? Tick number. N seconds over ticks. Seconds. How many seconds? It has to be proportional to n. This is like always just 1 second. So 1 second divided by 100. That is correct. That is correct. Why isn't it working? I followed you. I want to see it. Show me your development. I'm not on Twitch very often. If I happen to see you live, I'll stop by. Ugh. I don't get it. 1 tick per second, bro. 1 tick 1 second. Oh yeah. I'm using nanoseconds for my time precision. So every single collision is precise down to the nanosecond. That's actually a lie. It's like 20 order magnitudes more precise than that. I'm using a ratio of two 256-bit numbers. A ratio, a fraction. I couldn't help myself. I've written 3 computer algebra systems before. And I was like, oh, well, I could just make a ratio and then it'll be exact. Oh, yes. Yes, it is exact. But, okay. Hear me out. Let's say you're moving in the game, right? And it returns a time of intersection with an object. But you're moving fast. You're moving like 1 billion units per second. So 1 nanosecond is now 1 unit. So it's not accurate. So in order to get perfect accuracy, you need to have the solver solve with a ratio of these giant numbers. And then when you plug in the time, it's exact to the unit. That's why. But like 256-bit numbers. Yeah, man, let's go for it. I'll show you the code. A lot of this code is available. It's not fully open source, the whole project. So this is the project. The repo is public. And the libraries here, these ones are open source, MIT license. But the engine is copyright me. So don't copy my engine. But my little library things here are open source. And that does include this fixed point numbers, which I do not recommend you use. This is begging for const generics, where you can do an array of size 2 times an array of size 3 and multiply together and get an array of size 5. Array of digits. So fixed point digits. So this is the representation. I'm just using a stack allocated signed integer that's a fixed number of digits, and the digits are 64-bit integers. And that's all well and good. Until you try to multiply them together and widen it. This will get real ugly. Oh, I have float conversion here. So fixed point with an arbitrary fractional thing. And it should like work pretty good. I think there's some bad cases in here, but it's not pretty. But it does the job. Where's the real ugly stuff? My idea for fixed point was to use a backing int and use fixed point to the decimal. Decimal is in base 10, or decimal is in the binary decimal point. Decimal point. Gluten. Is that a bend? I don't know German. A bend. I don't speak German. Where's the ugly stuff? Macros. Let's go macros. Not const generic. Multiplicative. Multiplicative? Is that like mul-add? Mul assign. Non-assigned method. Yeah, Rust is not easy to read when you don't know Rust. So don't worry if you can't read it. Especially this. This is macros where it's like generating code with other code. Wide mul. Fixed to the decimal number. Really? You're going decimal. I would never. Base 10. Very weird. Jesus, where's the like as stuff? Mul macro 16. Yeah, of course. Mul assign mul. Jesus. Oh, it's here. Multiply operator, not constant generic. So, this is so difficult to read. Widening mul, unsigned. Oh God, and I have an if statement right in there. Terrible, terrible. Transmute. Mega match function. That's in the asset tool though. That's like, who cares about the asset tool? The mega match function is awesome. We love the mega match function. So yeah, this is the trick, the widening mul, where it gets the low bits and the high bits, and then we're doing width times 2 as the output. So you have a 64-bit number and a 64 number, and you multiply them together, and you get a 128-bit output. But it's yeah, okay. Let's scroll until we see that. Yeah, there it is, the triangle. Yeah, the triangle. So I have multiplication implemented for these widths. So 2 times 1, 3 times 1, 4 times 1. 6 digits of 64-bit numbers times 4 digits of 64-bit numbers will give you 10 digits of 64-bit numbers as output. And then these ones are implemented special case because there's that special widening mul function that makes it fast. So these ones are like really slow because like it basically widens 3 to 10 and then multiplies 10 digits by 10 digits. And then it's really inefficient. It's like 7 of the digits are just zeros. It's not good. I added one extra because I needed that one. Oh, buh. There's also this. This is one of the secret techniques as well. So this is solving a parabola, which you need to do for parabolic mesh tracing. Solving a parabola for arbitrary width fixed point integers. I also have square root. Where's the square root? I think the square root is at the bottom of here. There it is. So how do you do the square root? Well, let's see if I can remember how this works. I think I literally just binary search, but it's a little bit smart. Where it like inserts the top bit as 1, and if that number squared is bigger than the input, then we set it back to 0 and set the next bit to 1. If that's bigger than the input, then we set it back to 0, set it to 1. Yes, it's not bigger than the input, and set the next bit to 1. And so it's a binary search, just setting each digit to 1. And it's kind of slow. When is this used for? All the time. So in the face crawler algorithm, this is the algorithm that's like tracing the closest point along the faces. Let me just get back to the boilerplate. So we have a fev, which is a face, edge, or vertex. And this function, okay, why don't we look at the bottom first? Crawl. So crawl is crawl across the faces. So this is the time bounds, the lower bound and upper bound into giga time. That's the 128-bit time. I just called it giga time. Excuse me. 512-bit time. It's a ratio of two 256-bit numbers. Let's go look at it. Fixed 4. Yeah. Wide and wide. Jeez. Where were we? Face crawler. Okay, so how does it work? So you start with the current closest point, and that's self. That's a face, edge, or vertex. And then you find the next transition. So the closest point is moving along a parabola. So that'll move the closest point along the surface. So if you have a surface, it'll move the closest point along the surface until it reaches an edge. And that is the next transition. Next transition, it finds the next fev that the closest point transitions to across the crawl. So transition, that's this big function. So we're just trying to find the soonest transition. So if we're on a face currently, that's this case. This is an edge. If we're on a face, then what's the normal and offset of the face from the origin? And then it solves the time of intersection with the face. So if we're get my props out. So if you're crawling across, let's say you're tracking the closest point to a point across the surface of the mesh. So it starts here, and it like crawls up, transitions, crawls forwards, and then it intersects this face. So that's this case, face. We're checking to see if the parabola intersects with the face. And these are the lower and upper time bounds. Is the time of intersection within the allotted time? And is it going into the face? If it's coming out of the face, it's not valid. So this is just a dot product with the face normal. So the body extrapolated velocity. So body is a position, velocity, and acceleration, and a timestamp, which describes a parabola. So for each solution in zeros of this polynomial, degree 2 polynomial, where there will be 2 solutions, 2 or less, it checks to see if it meets all the conditions, and then, we found the new best. Great. It looks like, right. If one of them hits, the other one does not hit. So yeah, that's a hit. So that's, we can see that at the bottom here. Transition hit exits the algorithm because it's actually intersected. So that only happens for faces. You can't hit the edge. It'll always go to the face case, and you'll be just like on the edge of the face. It doesn't have a you hit the edge case. Oh gosh, I gotta eat my din din. So that's what this is used, zeros. And then zeros calls square root right there. Right there. Oh, I wrap it instantly. Yeah, makes sense. It's to understand when you jump into the right position. Quit dev work. This is like the most my biggest bestest ideas. It is definitely complicated. Okay, so this is the exit case for the algorithm. This is when you hit a face. If you didn't hit a face, then you might be about to hit an edge. So you're like tracing across the surface, you're going to hit an edge. And it needs to transition onto the edge and track the closest point like that. And that's here. So what face edges exist for this face? For each face edge, what's the edge normal? And then it solves another parabola and figures out if you're like exiting the volume above the face. So there's like a square that comes off and goes up to infinity. If you're going through one of those planes, you're going to transition onto the edge. Voronoi? What did I call it? Voronoi column, something like that. And it changes the upper bound as it goes as well. So it's like narrowing the times that are valid. Does that make sense? Break. Transition hit. It has to beat this one. That's right. Because it's like finding the soonest. So do you hit an edge? Well, you've transitioned onto the next edge. Great. And that's the end of the face case. So then you might be on an edge and you're trying to find when you exit the edge. So that's here. So for each edge face, so this is the edge, and then these faces are next to the edge. So this iterates over those two faces. So for each face, get the normal, and then find the time of intersection. So it's a parabola. It has to intersect the Voronoi column of air above the face to see if you're going into the wall. And that's the dot product. You have to be going into it. If you're going out of it, it doesn't count. So this is edge transitioning to face. But there's also edges transitioning onto vertices. So this is edge verts. So if you're on this edge, there's two vertices, and this is iterating over those two vertices. So if let's use a different orientation. So let's say it's like this, and your starting point is here, and you're tracing it. I guess we should do something crazy. So your starting point is here, and you're like tracing like this or something. So you're going to like follow the surface. You're going to go onto an edge and trace the closest point along this edge, and then along the surface, and then back onto an edge and onto a face. It'll like go here onto an edge, onto the vertex, and then onto an edge, and then onto a face. It always goes like up one level or down one level from a face onto an edge, onto a vertex, onto an edge, onto a face. It can like go up and down between those levels, but it doesn't jump from face to vertex ever. For the transitions between the fevs. And then if you're on a vertex, the only transition is down onto an edge. So you go vert edges. So if you're on this vertex, it checks to see, are you going to go down onto any of these edges? Understand a little, yeah, it does how it happens in game. That's a whole nother 10 minutes of explaining. We could omit the Minkowski sum and just imagine you're a little point that's jumping around. You're a little grain of sand that's jumping around. So if I'm trying to find the time of collision with my grain of sand and a platform that exists in the game, so like here, this platform, you can imagine that it'd be useful to like crawl across the surfaces and trace the closest point. And then when I hit it, it knows the time of intersection and it can go, oh, you hit it. We have to jump now. So that's what it's doing. That's how it's doing it. There's more complications in there where you actually have a hitbox, right? And your hitbox has to hit it. You're not just a grain of sand. But the same algorithm works, actually. The face crawler algorithm, you can sort of trace the faces like this as you like crawl across like that. It's because in the program doesn't understand that you're in the air. It actually explicitly understands that you're in the air, but how does it know that you've collided with something? Well, it has to do all this math to determine the time of collision. So in the physics here, this is the move state. So you can be in the air, you can be walking, you can be on a ladder, you can be in the water, and you can be flying. And those are the 5 ways you can move in this game. So fly is this, I'm flying. And then this is in the air. And then this is walking. Is there any ladders in this map? Yes. Ladder is actually the same as walking. It's just walking vertically. I'm kind of lazy. Mushroom. Oh, I actually did what I was set out to do today, but I never... Oh, how did that happen? I never wrote the unit tests that I wanted to write to like test the functions. Oh, geez. Ah, geez. All right, I'm just going to take a little break and play the game. Actually, it might troll me. Flat pack. Is Roblox going to work? Might have distracted you. Well, I love answering questions. It often helps me to understand things better. So this is my Roblox game. Looks like it's working. I wish I could get better FPS, but Roblox ruined the FPS cap. I used to be able to get 1,000 FPS. So Roblox actually doesn't officially support Linux. But there's a hack together client that uses the Android client. And it runs like 2 times better than Windows, the Windows version, which is hilarious. So on Windows, I never really broke 400 FPS. But with the Android client, I can get 2,000 FPS if there's not a lot going on. Hilarious. And that was really excellent. I actually set a bunch of personal best times on maps because the FPS has so much value for gaining good. So I just had wind at my back. Ah, jeez. And I would just beat all my times just by playing on Linux, which is hilarious. Yeah. So you can see this is very reminiscent of the Strafe Client game. Do you play Momentum Mob? Momentum Mob just came out with its first open public beta, right? I don't really. I've gotten so used to my the random numbers I chose in 2015. So in 2015, I copied some random Garry's Mod server in terms of how long the jump is and how like how the game feels. I copied it from a random Gmod server. Kind of. I just kind of winged it. I really should have copied the exact parameters from CSS, so there's not two versions of bhop maps, and it would be way easier to port the maps between CSS and Roblox because you could just use the one-to-one scale and it would play just as well. But alas, I wasn't that forward thinking in 2015 when I wrote the game. I was writing it for me. I was like, you know what? I think I can make bhop. And then I made bhop. And I was like, awesome. This is so cool. And then people started making maps for the game and people started playing the game. People were joining while I was developing it. I was like, hold on. This is different. This is something else. And now there's like 1,000 maps on bhop and surf. It's crazy. And then these are the maps that are not released yet. There's a release schedule. And you can pay to play the maps before they're released. I make most of the money from Roblox Premium, where people are paying a Roblox Premium subscription to Roblox. And then if they play my game first every month and like they spend some time in my game, then I get a portion of that. And that's actually where I make most of the money and not from like microtransactions. I'm actually horrible at monetizing my game. I'm just like not good at it. Luckily for the people playing. There's not like ads in your face. But I wouldn't do that. I hate ads. I suck. So good. Monetizing sales and marketing. Yeah, I think that the killer feature of the like game engine thing I'm making is that I can build it for a web browser. So you could go to like bhop.com and just start playing bhop with no requirements. And that would be pretty amazing. Crazy engine tech and algorithms. Hell yeah. Marketing. Hell. No. I don't know the map. I'm just winging it. Do you have replays? So look at this. Spectate. Damn, I suck. What am I doing? This is like so slow. I could totally beat this. Like, what the heck am I doing? I should route the map and like beat this time. What is that? I suck. When did I get this time? I'm just going on the side. 2022. Oh, I got this time like right after I published this new update. Is this a world record? No, this is my time. Here's a world record. It's quite a bit better by 15 seconds. So one of the benefits I give to people who join the game with Roblox Premium is every one of their times saves a replay, saves a bot. It's quite a bit better. I think I could get within like 5 seconds of this if I grind out the map and route it. I'm pretty good at the game. I'm pretty good. It's your time. Yeah. Big gaps. Between the platforms at the end here. Yeah. Oh, it's doing 3. Secretly quats alt. Replays. I asked if you have replays for your Quake thing. You said it's early time, so probably not. Replays is kind of crazy. If you're not thinking about it from the beginning, it's very difficult to add in. It basically requires you to build the game from scratch. So how replays work on the Roblox game is simulation outputs. So it just writes down position after position after position after position. The player was here, then they were here, then they were here, then they were here, and then it just interpolates. That's kind of the obvious way to do it, right? And that's fine. But how the replays work on the Strafe client is simulation inputs. So I can go run this, and then I can say, press B, and it's actually re-simulating the physics. And it's feeding in the inputs with the exact same timestamps, and the physics are deterministic. And so it's want to do input simulation? Oh, it's you really need the fine control over your simulations. So do you remember the state machine that I showed you right here, where it's like this? So each loop of this, oh, that's actually not sure. There's actually different layers where it's running this loop, and you can like monitor the instructions that are being fed, processed, and just process those same instructions. And that actually is different for each layer. So what do I mean by layer? So in the engine, there is the session, and that's like the entire game client. And then the session has input instructions. The session is a state machine. So you could monitor the input instructions going into the session and then replay the inputs and recreate the game session itself. Very cool. So then the session, where session? Help session. Who has session? Session playback instruction. Session. There it is. So this is the session state. The session contains the physics simulation. So in the simulation, the physics simulation, we have a simulation timer and then the physics state. So there is the root timer. That's like your system time. There is the session timer that starts at 0 when you open the game client and just goes up. And then there's the internal physics simulation timer. That's actually, where did it go? So that's actually this one. This is the session simulation timer. I have this like timer tree in the Roblox game, but I realized that I can actually just hard code it, and the code structure is what defines the timer relations, which timer relies on which parent timer. Oh my God, this code is so nice. The timer code. It's, you take the session time as input, you run it through the timer, and then you get the physics time as output. And that's what physics time you should be at if you're at this session time. So then in the physics also has instructions, but it has these internal instructions and input instructions. Which one is it? Instruction, physics. Where is it? This right here. So these are external inputs, but then these are internal things that can happen. So let's look at this one. So mouse, this is like to do with the operating system not giving no-op mouse movement. I needed an entire mouse interpolation state machine that handles a bunch of different cases, because the operating system doesn't say the mouse didn't move. If the operating system just said the mouse didn't move, it would be so much simpler. I have this like whole like thing. Anyways, control set move right. Yeah. So did you press W down or let go of W? Press. These are like which keys are pressed. Mode. So you can reset, restart, and spawn. Those are probably reset. Fully replace the physical state. This forgets all inputs and settings which need to be reapplied. Restart. Teleport to the start zone. Runs when you press R or teleport to a bonus. Spawn. Teleport to a specific mode spawn. This runs when the map loads to put you at the map lobby. Huh. Interesting. I might change those. Fly. Hey. Set sensitivity. So yeah, these are all the external instructions that can be sent into the state machine. And because this is the only way to interact with the physics, actually that's a lie. There's one other way, and that is loading the map file. Physics. There's so much code. Hell. Okay. Physics state. Physics models. New. Did I change it? Anyways, yeah. So there's only one way to like run the physics, and that's by sending an input instruction. So it's so easy to just write down the stream of input instructions and then rerun the stream of input instructions. As long as your simulation has determinism, which is tricky because hash tables have random state, and the iteration order is different for every time the game runs. UX research. Yes. The reason I wanted the game session to be a state machine is game crashes. I thought like if as you're playing the game, it's writing out the session input instructions to a file, and then it crashes. It should be able to write it first and then crash, so I can just run it and recreate the crash. Yes. In main behavior, I actually have no UIs at the moment. I actually can't render text. This is a overlay called Mango HUD. That's a separate application. I can show you. Look. So I keep running this script. If I just show you the script, Mango HUD, strafe client exe, map. So it just passes the map file as an argument to the game client and just loads the map. And then the Mango HUD overlays itself. I can't draw text. This is an image. I don't have fonts. I'm drawing polygons. How do you trigger the file writing on segfault? No, I would just be constantly writing. Every time there's an input, I would write that to the file first and then simulate it. So write it and then run the state machine asynchronously. The game is most in Rust. The game is completely in Rust. I think it's pure Rust. Of course, it depends on libc, but doesn't the file socket lose info in crash? Well, it'll be on a separate thread or something. Yes, it would like fail to close or something, but it shouldn't be a problem as long as you tell it to write the information and it's already in the like pipeline and it's like gonna do it. It doesn't really matter if the application crashes, and as long as like the file format doesn't need to be like fixed up after the fact so that it knows its length or headers or something. Yes, physics, go physics. Oh, I'm in Roblox. Practice. That might be tricky. Damn. 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 Really? Okay. Oh. I can't glaze Rust enough. It's so amazing for so many things. So one thing is the project structure. You see how it's like split nicely into modules, like the session module, the physics module, the graphics module. Awesome, right? And all these libraries. I basically just spammed files in without worrying about modules. And then I would run into like Rust borrow checker problems where like you're trying to modify this data while it's immutably borrowed, and that's not allowed. And then I'd go like, okay, if I do it this way instead, then it would fix the problem. And then I like reorganize the code to do it that way instead. It like naturally just cleanly splits after I can go like, oh, this actually looks like a module. It sort of just naturally evolves into clean modules. Appeasing the compiler makes you slow for game dev, which requires fast iteration. Never used it beyond tutorials. Yeah, so if I was doing like objects, like I need an item that does this, then yeah, games are just a big ball of mutable state, right? So Rust is a bit less like, if you look at my physics here, this is a function with the, yes, mutable. So this is a big ball of code, the physics, right? But it makes sense. It's when you teleport, do you really need all this mutable stuff? Well, when you teleport, you might start touching something, and you're moving the body. You're moving your main thing, right? You might change from in the air to walking, or walking to the air. Run state. So this is interesting. This is does it include the timer? Yeah, it does. So this is your current run of the map. So like, it contains. Does it not contain? Oh no, there it is. The timer. When you enter the start zone, it creates. You have created a new run. When you leave the start zone, your run is started, and the timer is running, i.e., it is unpaused. So this is a type of timer that is always unpaused at a type level. And then this is a type of timer that is always paused as at a type level. When you hit the end zone, your timer pauses. I call the pause function, and that converts the running timer into a paused timer. And then that like forever seals your final time into the finished variant of the enum tagged union. Rust on iteration speed. So yeah, the Rust compiler basically forces you to write correct software, write working software. So if you're trying to write some dumb thing that maybe has some problems, it's going to be like, well, this is an edge case. And you're like, I don't care about that right now. I'm just trying to make it fast. Maybe it's not the best thing to, but I already have made this game. I already know how the game works. So it's pretty good for like setting it in stone, carving it into Rust. But if you're like making random games ideas, then, you know, like generally people don't rewrite software, but I'm a big fan of rewriting for fun. There's really not a lot of good reasons to rewrite software that's working. It's almost always that it's a new software project that is like unrelated to the old one, and it has new bugs, new features, and new everything. It's generally not a good idea to try to replace. But I say that having done that twice now, so replace my old software. I had a back-end system for the Roblox game. Is the Roblox game still running? Yes, it is. Okay. I had a back-end system for the Roblox game written in Python, and I hated Python so much that I rewrote it in Rust. And it took down the entire infrastructure for the game. Because I didn't limit the amount of concurrent operations that could run. So it would receive a message from the game server, go like, oh, I can process that, and then like start like firing off all the stuff it needs to do at the database. Database was like, oh, like I can't keep up, and the Rust was like, oh yeah, new job, I can handle that. Yep, state machine, new job. The database just could not keep up with the RPC handing out the queries to like fetch this time, add this new time. And it took down the entire infrastructure because the number of concurrent jobs became like 8 gigabytes of concurrent async await state machine stuff. And the rest was just like, yep, I can do it. So I limited it to 6 concurrent jobs, and then it was fixed from then on. And it used 4 megabytes of RAM instead of 8 gigabytes. But yeah, I learned a lesson about limiting concurrency. Rust, have you heard of Rust's fearless concurrency? Oh. Never heard of that. The idea is that when you're writing multi-threaded code, you're constantly scared in like all programming languages of like data races and mutex locks and all that multi-threaded stuff. But in Rust, the standard library has expressed the invariance that must be upheld when writing multi-threaded code to never have any problems with data races and mutex locks and all that stuff. So if your program compiles and you're doing like multi-threaded stuff, you can be sure that it won't have those problems. So you can fearlessly write concurrent code in Rust. The mutable and immutable references are part of that, part of the restrictions that allow you to make those types of amazing guarantees. Where's some crazy multi-threaded code? Probably in the asset tool. Oh, we can actually take a look at the Giga match. Yeah! Oh, so the match statement, the compiler proves that you've exhaustively covered every possible case. So this is a triplet of results, and results can either be okay or there's an error. It's an enum with 2 variants. So when you match 3 results, maybe the first one is okay, and then the other 2 are errors. The second one is okay, and then the other 2 are errors. Or the third one is okay, and the other 2 are errors. And in that case, if there's exactly 1, then extract the value from the one, the unique one. And then, so this is like, I'm like matching against searching for 3 different files, and I want to only find 1. So if it's ambiguous, then I'm saying it's ambiguous as an error. So that's what this silly function is doing. There's probably a better way to write this, but like I knew how to do this, so this is now with 4 of them. So this thing is, it's reading files in a file structure and constructing a Roblox place file that gets uploaded to Roblox. And it's reading files in parallel, asynchronously. File read to string, file.file, file with name, file name. Well, that's obvious. Okay. Read to string. God damn, this is not clean code. Okay, where's the like asynchronous part that's like neato get file async? Rust is very unreadable when you don't know Rust. Is goober. Reject goobers. Roho, bruh. So this is mostly asynchronous code here, which can, asynchronous code can be parallel, and it can also be concurrent. So it can be on one thread running like multiple concurrent jobs, or it can be on multiple real CPUs running in parallel. What is this? For each reader. Future stream. This is the thing I wanted to find. What the heck? Damn. Okay. Futures. So this is concurrency, not parallelism. Thread the needle. Follow the path that dir takes. Dir goes in here, comes out here, goes in here, comes out here, goes in here, and then that goes away. Dir one goes in here, and it's done, and it comes out here on the next iteration. Of course, obviously. I made it too complicated. Where's the concurrency? This is so not nice code. Oh, it's spawn. So this is spawning a new thread. Well, a green thread in the Tokyo asynchronous runtime. So what is this doing? Metadata. File metadata. So this is like returns the metadata for the file. Metadata is directory. So I want to figure out if it's a file or a folder. So it's spawning a thread, reading the file metadata, compile node. All right, this code sucks. This code is ass. Session terminated. It's doing 32 things, 32 jobs asynchronously, reading like 32 files at a time. But this code is ass. Session terminated. All right, what else can I look at? Maybe we can look at the game RPC. The game RPC is cool. Yeah, I think that's a good one. Okay, so what is this? This is still async. It's not parallelism. It's still cool. It's still cool. What IDE is this? Yeah, this is zEditor. So this is the game RPC. The game RPC receives requests from the Roblox game server to do some like remote procedure call, RPC, like open a new server, create a new server. So the create server request is like, I am this server ID. This is the current place ID. This is the time that the server started. Is this a VIP server? This is the first user to join the game. And it has all the information needed to like create a new server. This is the current player list. And then this is the procedure. So what's up first? So we have a future. So this is, I should tab this in here. So this is a asynchronous block So this does not run yet. But within this block, we are creating a server on the server list. We are setting the map of that server to the current map. We are downloading player data for each player in the game, doing that concurrently, and then collecting the results. And then that's the end of this this block. And then there's a second block, and that's the event service. What's the latest event? So the event service is world record announcements mostly. So it fetches whatever the latest announcement was. And then this is joining futures, if you've used futures in JavaScript or some other asynchronous programming model. So it's quite easy to express this block of code that doesn't run yet and then say, all right, run it. Run these two concurrently and get the results. And so it's like doing everything at once and fetching everything and then sending it back to the Roblox server, so that it's doing as much stuff as possible concurrently, but not in parallel. This is concurrency and not parallelism. Okay, so I think I have a one that actually is parallel, and that is the map tool on the Strafe project. Map tool, Roblox. So the map tool, what does the map tool do? So I have Roblox maps that like bHop Arcane, and Roblox has like parts in the map and textures and meshes. And I need to download all of the assets and convert it to my file format. So let's see. Is this parallel? Let me just look for parallel code here. Oh. Read entire file. Tokyo. Spawn. Ah, so there is permits here. Download assets. Semaphore. Spawn. Yes. Okay, so here is actual parallel code here. So thread available parallelism. So this is returns an estimate of the default amount of parallelism a program should use. So this is like the number of CPU cores you have. And it's wrapped in like type safety magic so that if errors happen, you have to handle them. This is a multi-threaded channel where you can send things from one thread to another thread. So you have a sender and a receiver. So these are the constructions, structures, data structures, objects. These are like this is the sort of programming model that is restricting the way you code in order to give you strong guarantees about the execution of your program. So that's the multiple producer, single consumer. We're spawning a new green thread within the Tokyo runtime, which does actually run on a separate CPU core, potentially, depending on the Tokyo scheduler, how it feels that particular day, which is a source of non-determinism. Paths, path buff. So this is a string that represents a file path. This is a semaphore. That is a huge type signature. So this is like a permit system. So I am acquiring a permit to operate a thread. And then when I'm done with the permit, I drop the permit, and that releases the permit so a new thread can operate. So this is effectively a parallelism limit. So only a certain number of permits are available, and so you have to acquire a permit to spawn a new thread. Okay, what the hell is this? What the hell is that? Unique assets. That's all the download assets. Yeah, so not just download. So this is unique assets, read file. So it's read file. Right. So this is actually reading files in parallel. So that also includes decoding the image if it's an image. Send result, unique assets. What is unique assets? Unique assets. Okay. So there's meshes, unions, and textures, and they are deduplicated in a hash set. Okay. Path. So that's each path. Okay, so it's doing that. Okay, so it's constructing unique assets from that path, and then it's sending it to the receiver, which is down here on another thread that's been spawned. So now this is downloading with retry. And then when the download finishes, it's sending textures to the send texture sender, which goes to the receiver, which is right here. And then this is the main thread collecting texture files. And then it converts the texture from PNG to BC7, the GPU, the compressed image format for GPUs, on multiple threads. So like pretty crazy code that's like sending things around with senders and receivers. You should see it run though. It like maxes out all the cores and then it's done. It's super cool. And like I wrote it and then it worked. Load from memory. DDS. Yes. Convert texture. So it's like running it in parallel. Oh, it's reading from the file system. What the heck? Man, I really did not care about readability at all. In line 411, some asset ID, is this a Boolean? So this is a result and a option. So option can be some or none, and result can be okay or error. It's an enum like this. This is an enum. So only one of these exists for the value. So it's either an IO error, or it's a map error, or it's a read error, or it's a load error. It's not like a struct that has different fields. It's only one of these variants. So this is either some or none. And if it's none, this is receiving an item from the texture sort of queue thing. If there's no item, this returns none, and the loop is over because it's none. There's no items left in the queue. And same thing with the permit. If it fails to acquire a permit because of some sort of operating system error, then that's an error variant. It's an acquire error, and you're done. You can't continue the program because there was some sort of unrecoverable error. So as long as there's no OS error and there's another thing in the queue, get the stuff in the queue and your permit to operate and do your job with the stuff. So it's like matching out of the enums the values to use. It's very dense code where it's acquiring, and that's a result, and then it unpacks the result, but only if it's the okay variant. So it's like very dense. Rust reminds you of JavaScript, but more hard. Rust definitely has some JavaScript influence, especially the .await, async await. So in JavaScript, the futures are eager. They will start running the moment they're created, but that's not true in Rust. In Rust, futures are lazy. They will only run when they are polled, when you call .await. So if I did this, it would break the program because it would exit before all the threads are finished and then be like, oh, the program's over. And it would go exit all the threads before they're done their jobs. So this goes and waits for all the permits to finish. And it makes sure that all the threads are done. So this is a blocking point. What about source? Await, unwrap. So unwrap means if this is an error, crash the program. It's sort of like, I don't care. Just do it, okay? And you write that if you're kind of like prototyping and you don't care if it breaks. This is a potential like breaking point for the program. So all you need to do to guarantee that your program doesn't crash is don't write unwrap, and then it won't crash. Kind of. There's other places where your program can break, but yeah, it's a crash because this function may panic. Its use is generally discouraged. Panics are meant for unrecoverable errors and may abort the entire program. Instead, use the question mark operator. So that's what this is doing. Question mark? Question mark? Question mark? So the question mark propagates the error up. So if there's an error, instead of crashing the program, it returns early from the function and returns an error from the result. So this can error, this can error, this can error, this can error, this can error. So at any point there's a question mark, you might return early from the function because it encountered an error, and it'll return an error from this function. How much time do you develop from Rust? 2 years or so. I learned Rust in a week or so. I did the rustlings exercises. No way. No way. Ugh. This is a silly thing. Quick start. So you do this, you do this, you do this, you do this, and then you're doing the Rust exercises. And it's a series of Rust programs that don't compile, and your job is to make them compile. I learned Rust very quickly. I went from like not really knowing how to read Rust to I can actually read Rust, and I could try to make my own programs. And then I made some like little tiny software. And then I started making the game engine after a month. And I've been doing it ever since. What about Source Engine? Oh, is that all in one step? Right, so this is download the assets. There's 2 steps for this. There's convert the file after the assets are downloaded. And then there's download the assets ahead of time. So you download the assets and then you convert the file. Nice, easy 2-step process. And there's no chance of downloading when you're just trying to convert. I do the same thing for this one, right? Extract textures. Right, there is no download for this one. It's a little bit more complicated. No, it's two-step. Extract textures, source a sniff. And then these are just like, show me what's in here. Buh. Parallelism, thread limit, MPSC channel, send texture. Give me them textures, boy. Receive texture, receive. Load VPK list. Really? Convert images. Very cool. This thing is really cool when it's running. I don't need to run it right now, though. 2 parts, it's going in concurrence. No, the 2 parts are like separate commands you would type in. You go extract the textures. It would go, and it would pull the textures out of the BSP files from source games, like CSS. And then it would decode the textures, convert them into BC7 format, and then save the files. And then that process would finish. And then you would type in a new command, convert the maps. And then it would read the textures that are already converted and make the output files. Same for the Roblox one, where it downloads the assets, converts them, and then use the completed assets to build a map file. I worked hard on this to try to make it fast. I got most of my assets before Roblox heavy throttled downloading from Roblox. It takes super long now to do this. The asset download is super slow. How's the time? 7 p.m. Whew. I started really late today. I kind of did what I wanted to do. I think I'm going to make a branch here. Strafe state. I'm going to write, is it actually running at the correct tick rate? I'm going to put that comment there and then drop this comment from master. All right. What else? What else did I want to do? Right, I was in the middle of that as well. Sure, I'll do that. All right, I'm going to go in here quickly and switch to the something branch. Oh, God. My branches. There's so many branches. There it is. Boom, boom. Where does this go? Oh, it's right here. Oh. Oh, come on. Come on, bruh. What do you mean? What? Oh, I'm stupid. What was it? Right, version 700. I was gonna change this to version 700 to match the database version. Welcome to version 700. Right. I was gonna change it to use non-exhaustive. This guy, this guy, this guy. Get out of here, dude. Get out of here. Okay, very nice. Got a check mark on that. Nice, nice, nice. Okay. Well, I think I'm done for today. How'd I do? 5 hours. Wow. I kind of was just kind of hanging out for a lot of that. But yapping on stream is also solidifying and refreshing my understanding of my code. So, hey. And I did do work. I did what I set out to do, even though maybe it wasn't that much work. I was kind of hoping to test the code, but I kind of just like implemented the thing that I needed to do to test it, and then I didn't test it. Maybe I can do that tomorrow, maybe not. I'll probably try to do it tomorrow. Drink some water. I've been drinking milk. Okay. Goodbye. I'll see you tomorrow. I lied on Monday that I would see you on Tuesday by accident. I intended to. Hopefully. See you tomorrow.